first two papers.
Okay.
Okay.
Let's go.
Okay, so we're live, I guess, and we're on Gary's channel. And a couple of months ago, we did a hangout where we looked at the first two papers of Mary Schweizer. And Mary Schweizer is the paleontologist who found the soft tissue in dinosaur bones. And Mary Schweizer's papers have been misused by creationists, and Mary Schweizer is not real happy about it. And she is herself a Christian, by the way. So what we did was we looked at the first two papers pretty much in depth. So we thought today we're just going to do like a review of the first two papers and then maybe look at the fourth one in the list here. Especially since we have some new people here, and I want your comments on everything. And I don't know if this is going to work here. Let me see, because my system gets a little funny about stuff. So what I'm going to try to do is I'm going to try to do a screen share. Let me know if it's not working, and someone will also have to do the screen share. Let me try it. It might be working today. Where is screen share? There it is, screen share. And I'm going to look at okay. This is being a pain in the ass. Let me see. Oh.
You're in front of the speaker, Jade.
Well, hang on a minute. No, I'm going to have to do it a different way. Let me just try this. I'm just going to have to do it a different way than I was planning on doing it, but it'll work. I'm going to close a bunch of stuff. And this should do it. If it doesn't work, somebody else, because last time it didn't, somebody else had to do it, but if it works this time. Okay, so let me go back to screen share. I'm going to close this, and here we go. Share.
It's got the screen share icon, but I'm not seeing any slot. Oh, there you are. Yep. Yep, Carruthers, bring the net. We found a live one.
There I am. Can you see it now?
Yep. Yep.
Okay. So, and can you hear? But if you can't hear me, just go ahead and someone else might. Title of the first paper is Heme Compounds in Dinosaur Trabecular Bone. Now, what trabecular bone is, it's the soft, spongy bone in bones. There are two kinds of bone. One is a hard bone, that's like the outer part of the bone, and the other side is the trabecular bone. It's a spongy kind of bone, and it's found, for instance, like in the head of like your femur or something like that. Now, I don't know if this is going to switch over here or not.
Yep.
Okay, you can see that. I'm checking. Can you see that picture now?
Yeah.
Okay.
Gotcha.
So you can see where on the upper right it says trabecular spongy bone. That's what it looks like, and then there's a cortical bone. So that's what Schweitzer is, the spongy bone. And
Yep.
she was looking at this, and let's look at the abstract first. The abstract really tells most of the story. 6 independent lines of evidence point to the existence of heme-containing compounds and or hemoglobin breakdown products in extracts of trabecular tissues of the large theropod dinosaur Tyrannosaurus rex. These include signatures from nuclear magnetic resonance and electron spin resonance that indicate the presence of a paramagnetic compound consistent with heme. In addition, UV visible spectroscopy and high-performance liquid chromatography profile consistent with a modified data. Finally, when dinosaurian tissues rapidly within hemoglobin, the most parsimonious is the presence of blood-derived hemoglobin compounds preserved in the dinosaurian tissues. Now, that may seem kind of complex, but it really isn't, because basically all they're saying is She used 6 different methods have contained heme.
I'm sorry, Beck. I'm sorry. I lost you there for a minute. Your audio cut out. Can you?
Yeah, it's a little bit choppy.
Okay. Okay. Can somebody else screen share this then? Take myself off screen share. I think that's.
But
Gary,
well,
are you there?
you read the part of the article you wanted, and then I lost almost everything you said after that. You were starting to say that it may sound really complicated, but it isn't.
Right. Okay. Can somebody else screen share it? Gary, can you screen share it?
You have to give me the things. Screen share it. Yeah, please. You want me to screen share it?
Yeah. Yeah, see, that's what happened last time I did this, is that,
Yeah, I'll have to stay muted as well, if you want to read it off as well. So just leave the link
okay.
there.
Well, you can always type something in the chat if you have a question, and or you want to add. So anyway, let me go ahead and continue reading while you or somebody else gets screen share going. So what I wanted to say is, this sounds really complicated, but it's really not. The beginning is, it just says 6 independent lines of evidence. So all it means is that what Schweizer did is she used 6 different ways to look at what she found in the dinosaur trabecular bone. And when she looked at it originally, it looked like it was heme containing. It had heme in it, or hemoglobin. Now, heme and let me try something a minute. Just for a second. I might just kind of occasionally screen share stuff to kind of okay. If you look at hemoglobin, hemoglobin is in our blood, and in the center of hemoglobin is iron. And this is where you may have heard sometime in your life that there is iron in your blood. Okay.
Sure.
So let me screen share this for a minute, and I'll show you the this is the structure of hemoglobin. Okay, when I share it, see it? Now, if you can hear me speak, hopefully, you'll see that iron, the Fe in the middle, that's iron. So this is heme. This is what heme looks like. And heme is what partly makes up hemoglobin. So I'm going to stop sharing, because apparently it doesn't work if I do that very long. So heme is a compound that makes up hemoglobin as iron in the center of it, which is important to remember for later. So what Schweizer did then was to use 6 different methods to examine what it was, and that's what they're listing. They're saying they used a nuclear magnetic resonance. They used UV visible spectroscopy, liquid chromatography, and so on and so forth. And so what she's doing is she's saying, okay, I use these 6 different methods, and these 6 different methods make it look like heme. As a matter of fact, that's one of the things when we went through this paper last time. We kept saying it looks like heme. Now, what you'll find in the amongst the creationists is they're trying to say that there was blood left here. This is what Mary is saying. But it says, it says 6 independent lines of evidence point to the existence of heme-containing compounds and or hemoglobin breakdown products.
Right.
Nowhere does she say there was heme there. Nowhere does she say there was hemoglobin there. And she certainly isn't saying there was blood there. It points to heme. That it looks like that's what was there at one time.
Right.
So if you look at the now you remember that picture I showed earlier. Okay, so the beginning goes, hemoglobin is a large multiple subunit globular protein necessary for gas exchange in living organisms. It has long been the focus of studies in molecular biology and was one of the first proteins for which structure and sequence were determined. A large body of data exists pertinent to its structure, function, and evolution. The amino acid sequence of hemoglobin has been determined for many taxa, making it an important tool in studies of evolution. Now, I think this is it basically tells you what it looks like and why it's important. It's important for gas exchange. It's been really heavily studied, and it's well understood. But the part that's really interesting is it says the amino acid sequence of hemoglobin has been determined for many taxa, making it an important tool in the studies of evolution. What this means is that hemoglobin is a little bit different depending on what kind of animal you're talking about. For example, if you look back at the abstract for a minute, it says, finally, when dinosaurian tissues were extracted for protein fragments and were used to immunize rats, the resulting antisera reacted positively with purified avian and mammalian hemoglobins. So in other words, whatever this heme was, whatever breakdown product that they were able to get, they used a process that's well known. You inject it into rats and you get antisera. It's similar to the way that we get vaccines, right? You take a you take a virus or whatever and you kill it and you inject it and you get the antisera, and so it's a similar kind of process. So when they got the reaction. They said it reacted positively with avian, which is bird, and mammalian hemoglobin. So that's pretty cool. So it looks like whatever kind of heme it is, it's related to birds and mammals. Okay, and it goes on talking a bit more about the structure and about some of the analytical techniques they used and how it reacts. And for one thing, it points out, it says the portions of hemoglobin that interact with the heme prosthetic group are highly constrained and conserved across vertebrate taxa. Consequently, these regions of hemoglobin are appropriate for determining deep divergences. In other words, depending on what kind of animal you're looking at, you can really tell what kind of hemoglobin it is because it's constrained. In other words, it's really points to that kind of animal. It doesn't vary a lot within that. So it's really good for looking at lineages. Because if you, like in this, if you get something that reacts positively to bird and mammalian sera, then it must be related to birds and mammals. So this is what she's explaining that. And she says other regions of the molecule allow for much more variation and are more appropriate for determining closer relations, even to delineating species. Additionally, the association of the hemoglobin molecule and its organophosphate allosteric effectors may be a useful indicator of metabolic rates. Okay, so that's a whole bunch of words, but basically what it's saying is, okay, heme is really useful for looking at certain taxa. Other products are really useful for even getting closer, even down to the species. And you can also get some indication of the metabolic rates of the animal. This is really cool. So with just something like this, just these remnants of heme, you're going to get an extinct animal and possibly even its metabolism. So that's really cool. And then she goes on to describe a bit more of what it looks like. And this is the kind of thing, is like you can look up, you can read through the paper and you can look it up and just do a Google search for what it looks like. And then she talks about the it says hemoglobin crystallizes fairly easily, and in crystalline form, the stability of the protein may be enhanced. Now, one of the questions that's been asked is, well, if this is millions of years old, how did it last so long?
Yep.
Which is one of the things. Right. And so she's saying hemoglobin crystallizes fairly easily, and in crystalline form, its stability may be enhanced. Not only that, the stability of the core porphyrin ring may also contribute to the longevity of this biomolecule. And hemoglobin fragments containing antigenic compounds have been identified in fossil bone up to 4,500 years old. Blood residues bearing antigenic properties have also been isolated from stone implements up to 100,000 years old. In some cases, erythrocyte cellular morphology has been reported to be preserved to the extent that pathological conditions can be recognized. They're talking about blood cells here. In some cases, they've been preserved so well. So the structure of this lends it to being preserved for a long time. That's pretty cool. Now it says most erythrocytes, blood cells, undergo hemolysis when the organism dies. That means it breaks down. Hemoglobin is released with the resultant red discoloration of surrounding bony tissues. Now this is important because you see a lot of these creationists go, but it's red, it's blood, it's red, it's blood. It says no. Okay, so the blood cells break down, hemoglobin is released, and you get a red discoloration of surrounding bony tissue.
Yeah.
So just because it's red, it's not blood cells.
So it's essentially a chemical reaction.
Exactly. And then she goes on to say, however, under the anoxic, in other words, without oxygen, conditions that prevail deep in the endosteel tissues of massive animals. So if you've got a great big huge animal like the Tyrannosaurus Rex, and you're going way deep into the tissue where there's like no oxygen, where was I? Anyway, there's a greater chance for it being preserved because it's protected. And it may be protected. She goes on to say hemoglobin molecules may be protected from early stages of oxidative degradation. The proteins may then become complex with apatite, the mineral phase of bone matrix. This association may well be a prerequisite for the survival of biomolecular compounds across geological times. Now, there are a lot of references for all this, too. You'll see, when you look at the paper, there are all these references. The research has been done that goes before this, because anytime someone writes a paper, it's built on a huge hill of other papers, a lot of research. Now, let me make a point here that is relevant to the way creationists look at papers. You'll notice she says here, under the anoxic conditions that prevail, hemoglobin molecules may be protected. And then she goes, the proteins may become complex, and the association may well be a prerequisite for compounds. Now, what happens is you'll see creationists go, well, see, it's just speculation. She's just saying may. It may happen.
Yeah.
The thing is that scientists generally don't say things are for sure.
Yes.
Unless they're absolutely for sure. So what she's doing here, excuse me, is, hang on just a sec. Sorry, folks.
Hello, room service.
Yes, hello. Yeah, that's utter nonsense. Okay, sorry about that, folks. I'm going to unplug the phone now, so it doesn't do that. I've done that before.
You may want to mute. You may want to mute.
Okay,
yourself.
no problem. Okay, so apologies. Oh, this is brand new. This is like, if this isn't her first paper, it's one of her earlier ones. So she's looking at something for the first time. And so what she's doing is she's going, okay, we're running all these tests, and we're looking at this. We're looking also at the research that's gone before, and we're looking for explanations for this.
Yeah.
This is absolutely what it was. Not only are they going to run a lot of tests, but other scientists are going to come along and check their data and look at other things. So we're looking at the very first, as I understand it, the very first sign of this soft tissue. And so, yeah, they're not going to say it is. It's just the way scientific papers are written. You can look at far more complex papers. I wouldn't say far more complex, but you can look at papers that have a lot of surety behind them, and you will still see people saying things like, well, all of this data points to this, so we think this is what may be. Yeah. It's just the way science is written, and unfortunately, you'll find creationists will grab onto that and say, well, they don't know what they're talking about. They're uncertain, rather than look at the evidence. I just wanted to point that out. So anyway, but she also points out, looking at comparatively, protein and other organic compounds are protected from degradation when stabilized by interaction with mineral crystal aggregates. So this is something known. Protein and other organic compounds are protected from degradation when stabilized by interaction with mineral crystal aggregates. In addition, by adsorbing to a stabilizing mineral matrix, biomolecules are effectively isolated from water, thereby retarding hydrolytic damage. So she's going, well, we think this is what looks like may have happened. The reason we think it may have happened is because we've got all this stuff that we know happens.
Yeah.
And then it says, traditionally there was little hope that biomolecules might be recovered from bone more than a few thousand years old. However, 20 years ago, partial amino acid sequences were identified from the shells of mollusks 80 million years old, followed with a report of amino acids in the bony tissues of the late Jurassic, which is about 150 million years ago, a sauropod dinosaur, Seismosaurus, and more recently the small and highly acidic bone protein, osteocalcin, has been recognized immunologically in extracts of dinosaurian bone. Stable isotope studies, including those done on the specimen used in the following study, indicate that at least some of these molecules are endogenous to the fossils rather than arising from younger exogenous contaminants. These results suggest that significant protein remnants may exist in fossil bone. In light of the above studies, it was decided to examine non-permineralized dinosaur bone for biomolecular degradation products, including hemoglobin. So this is, go ahead.
I also just read like a week ago or something.
Did you want to say something?
Am I talking? Can you hear me?
Yeah, we can hear you, Shara. I think there may be lag issues, but we can certainly hear you.
Oh.
Okay.
I'm screen sharing now too, so maybe that's part of it.
Oh, okay. Well, that's cool. Whoever.
No, I just last week or something like that. They said that they're finding bacteria, or at least single-celled organisms or something that they're actually able to examine because they've been preserved in salt.
Mm-hmm.
And they're like hundreds of millions of years old too. Like I think 350 million years old is like the oldest one that they think they might be able to examine now. So it's pretty neat that we're able to get stuff this old that we never thought we could.
And that's the biggest point, because they didn't look because they didn't think they could. And the story of this bone is that what happened, I'm pretty sure it's this one, but what happened is because of where it was, they had to cut it apart to helicopter it out.
Right.
And, scientists have to use whatever they've got available, and they don't necessarily have those great big huge helicopters like the Army does that will lift tanks. So you have to use what you can, so they had to cut it open. And then when Schweizer looked at the open end of the bone, she went, wait a minute, it's red. And our scientists have looked inside bone before, but, sometimes, scientists do make assumptions like, well, we just aren't finding this, so we can't find it. And then somebody comes along and says, well, did you look here? Or did you look in this way? And so Schweizer looked at that and said, this is really interesting. And this started a whole new look at so people are going back and looking at dinosaur bones and dinosaur tissues to try to figure out, what can we tell?
Yeah.
And further experiments are showing that there's more there than we thought. Now, when this was first discovered, one of the things people had to look at was were some of these things actually native to the bone, so to speak, or was it something that happened later due to a biofilm that covered the bones after death?
Right.
Like some sort of biological slime or something.
Yeah.
But this was inside the bone, so this is pretty clear. It wasn't exposed till it was cut open. So these are questions that that people have looked at for a long time, and it's really cool now because this is all very chemistry, as you can see, as you pointed out earlier, Chris, that this is it's chemistry.
And also, if in case people aren't aware, it was the biggest, fattest bone on the T-Rex, right? Like a huge bone.
Yeah, it's the leg bone, and I think the leg bone is had to hold the damn thing up. You've got an upright animal, all the weight is on those legs. So it's a pretty freaking huge bone.
And that's why they cut it in the first place, because it was too big to move.
Exactly. And this is why she's pointing out that, look, if you've got these great big huge bones, and because the center of the bone is so isolated from the outside of the bone in a great big huge bone, you've got a long ways to go, that it is somewhat protected. and that's where we may find some of this stuff, and that's where, she found it. And she listed other, and again, there are studies here that you can look at if you want, and it should indicates at least some of these molecules are endogenous to the fossils rather than arising from younger or exogenous contaminants. In other words, biofilm or some sort of slime that covered the bones. And so it says these results suggest that significant protein remnants may exist in fossil bone. So they decided to examine non-permineralized dinosaur bone for biomolecular degradation products, including hemoglobin. Now, then she goes into materials and methods. It says, okay, a near complete specimen of the late Cretaceous dinosaur Tyrannosaurus rex was collected, and it says the completeness and articulation of the skeleton indicated the burial was rapid enough to forestall damage by scavenging and weathering, but not rapid enough to prevent some minimal displacement.
Right.
The specimen was surrounded by consolidated white sandstone, and it talks about, what it looked like, and this is all important because other scientists looking at this are going to question, well, could this have been this, could this have been that? And when this was first discovered, I remember this is when people were looking at it going, maybe it's some sort of biofilm.
Yeah.
And she examines, it says, preliminary examination of trabecular bone elements of the specimen revealed little or no evidence of internal permineralization or replacement. Excuse me. This relatively unaltered state may be due to minimal exposure to water. And again, this is the thing. It says dehydration would favor preservation of endogenous biomolecules, including hemoglobin, so an attempt was made to detect their presence. Darn it, I've got this. Hang on a sec. And it goes into more details, like gloves were worn at all time. We only use sterilized instruments because other people are going to read this. A lot of people have read this. And in the profession, they're going to know whether things were done properly or not. She explains how the tissues were extracted and what they did with the tissues after they extracted them. And then how they looked at them. She explained spectroscopy, and they explained how that was done. She looked at them. They looked at them through an NMR. She explains how that was done. She looked at electron spin resonance. She explains how that was done. Raman spectroscopy looked at how that was done. And then antiserum.
Yeah.
And the antiserum one is really interesting because she explains how it was used, how it was done. And then she also looked at something else. Then she goes how again more of how this test was done, and again for people who know what's going on, you can read through the. But then we go to results, and during the results she gives the analysis of all these different things and says, look at the UV, visible spectroscopic analysis. Look at all the NMR analysis and all the graphs and diagrams here to show you what's going on. And again, you can read through this. We went through it in more detail in the previous one. Sure. So if you want to listen to that and follow along with the papers, that's cool. And again, these papers are free. You can download them. You can look at them on your computer.
Sure.
So then we go to the discussion, and this is the kind of the good part, and we're almost done. We are skipping through a lot of stuff. We went into more detail in it. So independent results from all these different techniques, I'm paraphrasing sometimes, folks,
Sure.
Support the existence of heme and hemoglobin breakdown products and extractions of trabecular tissues. And it talks about a little bit more about the individual amino acids and proteins and stuff, and what the most likely source of these proteins and so on and so forth. A little bit more about the details.
Jane, question, please.
Yeah.
Sorry to interrupt you mid-flow.
No, that's fine.
But I just want to ask a question as somebody who's an outsider. Now, you keep on saying that creationists are making mistakes. Now, what mistakes are they making? And I'm going to say how I read this, and we now have the beautiful, lovely Fiona Robinson with us. I know she's not feeling very well, which I do.
Yeah.
Yeah. Sorry, Fiona, put you in a better way. But But this is how I read it: that they found blood traces on a T-Rex. Now, I'm going to ask a question that may seem a bit silly, but why would they find that? Because T-Rexes, from what I understand, are from, I'm not sure what exact period.
Late Cretaceous.
Like Cretaceous, just like, thank you, Zayna. Like Cretaceous period. Now, from what I understand, that was many millions of years ago. Now, why would traces of blood be preserved in T-Rexes?
Gary, I think it's down to they're preserved inside the bones. I think you're making the mistake, possibly that you're thinking of the blood outside of the bones. No, it's
because again, from what I understand of in actual bones itself, the blood inside the bones degrades as well, not as fast as outside, but the precious that make the blood inside the bone degrade as well.
Gary, Fiona has her hand up.
Okay.
Yeah, as soon as I heard Jade read this bit out, I'll go to Char's thingy so I can see it. It said about finding, where is it? It was the degradation products of heme and hemoglobin. Degradation products of them. So they didn't find blood. Because to find blood, they would have had to find red blood cells, white blood cells, serum, etc. They didn't find any red blood cells. Now, hemoglobin is a protein molecule, and at the very centre of it, there is a molecule of iron.
Yeah.
And that is how oxygen transport is carried out. The oxygen binds to the molecule and gets transported around the body.
Yep.
The molecule lives inside the red blood cell. If you burst a red blood cell, then you let the hemoglobin out, but you no longer have a red blood cell. If the protein component of the hemoglobin molecule breaks down in a localized area, then what you'll have is a whole bunch of fragments of that protein all sitting there, but they're no longer that protein. They're the building blocks of the protein. It's like if you've got a Lego house built and you smash down your Lego house, it's no longer a Lego house. It's just a whole bunch of Lego.
Yeah.
So it's not blood that was found. It's the degradation products of hemoglobin and heme.
Okay, I understand that, but the question still is that common to find in dinosaur bones of that period? That's all I'm asking. I'm not saying, oh, this proves of red blood. I'm just saying, like, is it common to find that? That's all I'm asking. And if not, then was there something special about the way that this T-Rex was preserved that helped that product to get more preserved in it than it is in it, maybe things that we found, other T-Rexes that we found around?
Well, see, nobody's looked. Because there was, if the bone is fully permineralized, then it's no longer a bone, it's a stone. The unique thing about these bones were they weren't fully permineralized.
So they weren't fully fossilized, is that?
Exactly.
Okay.
For some reason, the condition that the bones lay in prevented full permineralization.
Okay, so what do you think that the things that were that helped preserve it? Maybe there's things that maybe were there indicators of what it was, or
I don't think there have been any indicators as to why this.
I do think it is. I do think this particular bone is the biggest bone possible that one could find. Like, it is, like, it's right up there. Like, it's the 99.9th percentile of bone in terms of, like, size. So that alone is probably why. But yeah, they never look, because why would they? They don't expect to find anything.
Yeah, because you have to remember that a fossil is a stone,
Yeah.
Right.
and you don't usually get blood from a stone.
No.
No kidding.
Well, you sometimes may do with Jason Birds, but I understand that. But
Do you know, I didn't mean that to sound sarcastic or anything, but it is the first time that particular saying has been as appropriate.
I know, it's perfect.
I'm astounded at myself.
yeah, I know. I'm just. All right.
Well, Gary,
I'm just trying to understand it from my
Yeah.
purely
right. Well, she did point out.
scientifically educated understanding of what exactly was found. So
I had to imagine.
please correct me. So
But I mean, if you
it was the evidence of iron which points to many years ago there being hemoglobin constructs there.
Mhm. Yes.
Is that correct? Okay. So
That's what they're saying. And also that the presence of iron has actually helped preservation of other molecules. It's like, think
Sorry.
of it like the perfect storm of conditions just came together.
Sorry, just to clarify, are you saying the iron was present, or there were evidence of its presence? Good grief, that's
No,
it.
there was iron present.
It was present.
Yes, iron, an iron molecule.
Right. Yeah. I thought that's what you were saying.
Yeah. You know, molecules don't just they might leach out, but they don't just disappear.
Sure.
And it seems that the conditions in the conditions that this bone had existed for all this time had prevented the molecules from leaching away.
Yeah. Right.
And I would like to point out that Schweizer and others have done more work on how iron caused this preservation, or had a big hand in the preservation. That's in other papers, though. But they've been looking at iron as being key to the preservation of this molecule. And she did point out that it was deep in this bone, and as Shard pointed out, it's a great big huge bone, and the fact that you get to the center of the bone means it's preserved from oxidation, plus it was found in a crystalline form, and there's a whole bunch of other things that look, in this case she kept saying may, and I tried to explain that just means that this is what it looks like happened. But much more research has been done on this. This is just like the first paper out. But the big mistakes creationists are making is they keep trying to say there's blood here.
Yeah. If you look at one of the comments, it says the proton arrangements of iron or copper complexes normally found in geologically derived minerals do not possess the aromatic delocalization found in porphyrins. And yet that's what was found here. So it wasn't geologically derived.
Right.
Oh, he's gone.
Oh well, he'll probably pop back in, hopefully, because it's his hangout. If he doesn't, we'll have to do something else.
Yeah.
But yeah, so they had to rule out that it was geologically derived. They had to rule out that it was caused by some kind of other biological organism, like a biofilm of some sort. And they did that. He says his computer just got an error from Google.
Ooh.
Oh dear. So chances are.
Let me see if we can get back in or not. We may have to just start another hangout.
Yeah. What happens? We're still here at the moment.
Let me ask him. Let me see if he can get back in.
I think he can.
Let me see if he can get back in. No, see, that's the kind of thing we need. We need people asking what exactly. Why is this so misunderstood?
So
let me see.
Let me ask a question. Do you think that, like, obviously the outside, like the shell of the bone was fossilized, like fully fossilized, I would
Right.
imagine, right? So do you think that would help preserve the inside of the bone?
Sorry about
Yeah, it might.
It would.
I don't know, really.
Yeah.
sorry, my computer had a fart. Sorry.
Well, you're back and we seem to be okay. Oh dear. Oh dear.
Okay, but the thing is that like the problem with Fiona is that, and I know this is going to sound like I'm talking about people, but I'm actually talking about myself here. Because it's hard for people who are on your level to make it understandable to people who are on my level, if that makes sense. Because while I do have education, it's not in science.
Mhm.
It's in my degree's in English. So like, and I think the problem is that the two different fields. It's like it'd be like me trying to explain to you how to read Macbeth or how we do Macbeth does. You know, you because like you'd understand it in a very wooden way.
Yeah.
Whereas I think that the way that people understand like English and law and stuff like that, from what I understand, one of the major proponents of creation intelligent design is Philip Johnson, who I believe is some sort of law professor from Harvard, and I think that shows where maybe misunderstandings can come from. Is that when people go to another field where things are done a little bit differently? Do you think that's the case, or do you think it's more maybe intent?
I think there's a bit of both. For example, if you're looking at this paper, you have to read every single word exactly as it is written, and exactly what it means. Do not interpret it. Whereas if you're coming from a field of literary criticism or English, etc., where you go through all these things, you know, the author said this has a character say such and such, but what's the character actually saying there? You can't do that with a scientific paper because they are written deliberately to mean what they say and say what they mean. And there's no, the word has just gone to the tip of my tongue and fallen off it. But the subtext, there isn't a subtext. There's no reading between the lines. And so that's a huge difference. Oh, he's away again.
You've upset
Oh dear.
Yeah.
Yeah, well, we'll see if he comes back right away again.
Yeah.
Yeah.
Yeah, I was gonna.
He's back.
Oh, he's back.
Oh, go ahead, Cider Thinker.
Yeah, I apart from railing against Gary's characterizations of scientists not being able to explain things logically to English majors and vice versa.
I never said that.
Well, you pretty much did.
I'm saying they're two different fields, and
Yeah.
what I'm saying is that they can't understand. Again, the thing is that let's say, for example, Fiona tried to explain to me how this works. I'm sure I could get the gist of it. What I'm saying is that, and I'll take Philip Johnson as an example. What he did is that, from what I understand, and people are free to correct me on this, he took a scientific paper which he is not equipped to understand from his academic standpoint, because the way he understands like law is not the way that how science is presented. You know, as Fiona was saying, you know, it says what it means and it means what it says. Now, the thing is that I'm not used to reading scientific papers, and that's what I was saying. I'm not saying that, oh, we can't be shown. I'm saying that it's difficult to explain that to somebody who is unfamiliar with the field, that, especially when they're familiar with another field that doesn't do that. That's all I'm saying.
Yeah, I'll grant you that it's difficult, but an observation that I have is that I don't think it's nearly as difficult as people actually think it is. And I think there's a preconception about science and the way science is presented, and some of the language used that makes people think that it's far more complicated than it actually is.
I mean, that's true to a point. But I think the point that Gary's just made is the crucial one. That if all of your training is in reading literature and reading the subtext, so that you're always looking for the subtext, then when you go to do a scientific paper, you subconsciously do the same thing, just because you're always doing it. And it's very hard to switch that off.
Yeah, no, I'd absolutely grant you that. Absolutely.
Yeah, and this is what I think Gary's trying to say.
Okay.
So you need somebody who is used to reading a scientific paper to explain exactly what the paper is saying, but more importantly, what it's not saying.
Yeah.
To make sure that you remove the subconscious subtext that you're inserting.
Yeah. You're essentially looking for a study guide in a
manner of speaking.
Yeah, because like as I said before, Cider, like me and Fiona, last time we did this, he corrected me about a mistake I made. I believe it was this exact paper where I got the bare idea that it contained blood cells. It contained blood cells, and it's because it said the words dark brown and red. That's the things. And because I know enough about blood cells to know that they are different colours, I thought, oh, that must mean it had blood cells in it. That's just the way that my brain is tuned, to read the as you say, the context, the subtext of writings.
Sure.
But she correctly pointed out that, again, it never said that. What it was saying was that they were microstructures of blood vessels. Again, and my brain doesn't know how to deal with something written in that a woodenly literal fashion, I think, is the point.
Yeah. Yeah, you have to be very, very literal when you're reading scientific papers.
And to be fair, it's not. Gary said 2 fields. They're 2 different fields. No, it's like 1,000 different fields.
Yeah.
Because I'm an engineer with a little bit of biology, post-secondary biology, but I can't read these papers without having to look things up. Like it's not science as a field. That it doesn't work that way. It's so specific to every individual specialty.
Yeah, I mean, you watch. There's a video of on YouTube of Dawkins and Neil deGrasse Tyson in conversation, and they are having to explain things as they go, because even though they're both scientists, they still have massive gaps in their understanding of the other's field and the depth of understanding that the other one has in their respective field.
Well, and not only that, the different fields look at things different ways. When I was in college, I was a biology major, and I had friends who were physics and chemistry majors and math majors, and they found biology just totally kind of incomprehensible because nothing was for sure. It was very fuzzy to them. But you can't do a test and have it repeatable constantly like you can in chemistry. Every time you do a titration, you're going to get a certain variation in your results, but you will ultimately get the same line, the same conclusions. But in biology, biological systems don't work that way. You don't get the exact same result every time you test something. And they just couldn't understand how I found that fascinating. See, I found that part of biology even more interesting, and they found it just like really annoying but you can't do the same experiment every time and get the same results. And so even in different sciences, the approaches and the way people look at things are really different.
Yeah. Especially if you're working with higher organisms. I mean, how on earth do you control the 10 blue tits that you're studying?
Yeah.
Because there's always going to be one.
You asked the 5 blue girls nicely. No, sorry.
This is where, once you get your biological science down into the realms of biochemistry and chemistry, then you can get your reproducible results. But when you're dealing with whole organism, you're dealing more with a range.
Yes.
Even if it's dead organisms that you're doing necropsies on.
Yeah.
With a range of organ sizes or whatever.
Well, and I've watched, because I've watched what's been happening in genetics, not like super closely, but for the last 40, 50 years, and because I was really into it even as a little kid, and that there's always been this idea that genetics determines everything, your genes determine everything, but it's gotten more complex the more research they've done, and what's happened is that we now know that just because you have a gene doesn't mean that gene is going to cause something. Some genes don't ever get turned on, and now there's this whole field of epigenetics. So it's not. The more we study, the more complex it gets.
Yeah.
So yeah, that's basically. So anyway, what I wanted to say. Hang on a second, I've got to type something here. Anyway, what I was going to say, the last thing is, we've pretty much done with this. If people want to go with this paper, unless anybody has any more questions, people who want to can go listen to the previous Hangout and finish reading the discussion for themselves. We went through the discussion. The one point I did want to make about this paper, the last point, is you remember when they tested the sera against, it tested positive against mammalian and avian hemoglobin, right?
Mhm.
Yeah.
So what that indicates is that there is some relationship between Tyrannosaurus rex and mammals and birds. What was interesting, though, is that it tested negative against reptilian sera.
See, I was going to ask that question. I'm glad you brought it up because I got sidetracked. I was going to ask you if it related to that as well. So I wasn't sure if just to assume.
Right, and well, and that is in the paper. So what this tells us is this is very interesting, given all the other studies that have been done, and given the understanding now that a lot of Tyrannosaurus, the Tyrannosaurids are theropods, right? And we now look at birds as being theropods as well.
Yeah.
They're just a kind of theropod. Just stick with us here a bit, okay? So this I'm going to mute you in a minute. You know that?
Yeah.
Okay, so stop it. So what this tells us is that this indicates, and again, this is the way scientific papers are. You don't say for sure. What this indicates is that tyrannosaurids, which we look at as theropods, are more closely related to birds and mammals than they are to reptiles, which fits our new understanding of what theropods are. And we now believe that both mammals descended from theropods, and birds still are theropods. So this fits what had already been thought, and this is just another cool piece of the puzzle. So yeah, that's the only thing I wanted to say about this paper. So I thought maybe we could briefly go through the other one. Because this one's really cool. This is the second paper. These first two papers are the two that are often used by creationists. And the second one, if you look at the link up here, it's soft tissue vessels and cellular preservation in Tyrannosaurus rex. It's in Science Reports. And if you guys could bring that up, the link is up. Oops, I'm in the wrong place. Yeah, soft tissue vessels and cellular preservation in Tyrannosaurus rex. And this is the one that really has people going. Go ahead. Let me screen share just for a minute, because I'll screen share as long as I can. When I get fuzzy, someone else can do it.
I've got one, but what?
Scroll down.
Let me show you.
Scroll
Can you
down.
see this?
Here? No, I don't see
go.
anything.
Yeah,
Oh, there we go. Okay, I got it.
Got it.
Okay. So you can see those pictures there.
Yeah.
And you see how red the pictures are.
Yeah.
Yeah.
These are the pictures that are frequently shown by creationists. Okay. Let me see. This isn't the one that. Okay, this isn't the one that has that other. And they're shown because they show these. And they go, look, it's soft tissue. It's blood. Well, first of all, you need to understand that soft tissue is a type of tissue.
Mm-hmm.
It doesn't mean the tissue was soft. The first thing it says is soft
can I ask a question?
tissues are preserved within
What does it actually mean then?
limb elements of Tyrannosaurus rex.
No, I'm asking legitimately what does it actually mean?
Of the mineral
because if you're going to use a term and you say, well, does it mean blood? But what does it actually mean? Does it mean that the tissue is like some sort of thing that was in the animal itself that was easier to detect? What does it actually mean?
Look, could Char just go back up to those pictures again, the top of them?
Get to the to where the red.
Yeah, that's it, right.
Yeah.
Have a look at the bit that says Figure 1.
The one that says demineralized fragments of end australly derived tissues lining the marrow cavity of the T-Rex femur.
Yeah, it's from a bone.
Right.
Yeah.
And they've demineralized it.
Right. So what that means is it was permineralized in the first place. In other words, it was fossilized to some extent.
Yes.
Okay, so how can you defossilize something? Because that's
No,
all
demineralize.
Demineralized.
Yeah, you can demineralize using acids. And it hauls out everything that makes a bone rigid. Do you remember, you might have done it in school, your science teacher took a piece of bone and dumped it in, I think, hydrochloric acid.
Oh, yeah, I remember
And you
that.
all came back a week later and it was like rubber.
Yeah, I remember that.
We did that with eggs too, eggshells. You can
That
use
is
eggshell.
the bone being demineralized.
Okay.
Yeah.
Yeah, and
It's
this is
also
one
not.
of,
It's also not so different from descaling your sink or.
Yeah,
yeah,
yeah. If you descale your kettle, you're demineralizing it.
yeah, exactly.
Okay, so could I ask a question though? Like, could be like, does demineralizing something make it more easier to get like a soft tissue remnants or whatever it is? Or is
Yeah, it makes it softer.
Yeah.
So sorry, I don't asking stupid questions. I do apologize.
No, that's
I
okay.
apologize.
No.
I don't apologize to Fiona because I know that she's getting frustrated at what I'm asking. Because again, the thing is that I'm not used to this sort of thing.
Yeah. It shows you that in Figure A that it's once it's demineralized, it's flexible, and when it's stretched, then it turns to its original shape.
Okay.
But the part that a lot of creationists miss when they try to talk about this is it was demineralized. And if I'm correct, or if I look at the paper a little bit further, it explains how they did it. Yeah.
Yeah.
Well,
if-
can I just bring something up? And this is something recently. Didn't they find like a frozen mammoth? It wasn't like somewhere in like Florida, because my mum again was talking about it actually.
Yes, they found
That's actually frozen. Yeah.
Yeah. Shar, can you scroll down to like the bottom of the page? Okay.
Sorry, that's tangentially.
No, that's okay.
Sorry.
Okay, yeah, right there. That's good. Because if you look at Figure 2 here, and it talks about it, it shows you all the different pictures of what they saw, and it says, Figure 2, demineralization of cortical bone reveals the presence of soft tissue structures in A. That's A, this A, not the A from above. Partial demineralization of a fragment of T-Rex cortical bone shows an emerging network of vascular canals, some of which are bifurcated arrows. In other words, they split.
Okay, but what? This is going to sound stupid, but what does exactly this prove? Sorry, I'm sorry. I'm trying to wrap.
No,
my brain
don't apologize. Just ask the question. You're okay, Gary. Because remember, any questions you're asking are what other people are thinking.
Okay.
It's fine.
No, I just don't want to seem stupid. That's all.
No,
No,
but
no,
this
no.
isn't your
Gary,
area. So,
it's more stupid to not ask the question something you don't understand.
yeah. Yeah.
Yeah.
Right, so
what
so
is-
from what I'm reading, sorry, if I've misunderstood what I'm reading, right, so basically what is the these are the demineralized caudal bones of reveal the presence of soft tissue.
Mhm.
Mm-hmm. Yeah.
So what exactly is this proving? Is this proving that the T-Rex, well, not that the T-Rex was preserved better than its T-Rex cousins? What exactly is this proving? Sorry.
At the moment, it's not proving anything. We're just looking at it.
Yeah.
All right, sorry.
But, I mean, just looking at the legend and talking about the emerging network of vascular canals, if the bone had been fully fossilized, then all of that structure would have been lost.
Okay.
Right. And that's what it says in A. Partial demineralization of a fragment shows us. And then that one, they're only partially demineralizing. But yeah, if it had been completely fossilized, this would have been completely lost.
Mm-hmm. Because
And
it would have been purely rock.
Right. And it then says all are aligned in parallel, consistent with Haversian canals and cortical bone. So what she's saying is this looks like Haversian canals look in live bone.
Mm-hmm.
So we can, for the time being, suggest that maybe it's the same thing. We don't know yet because you have to look at it.
Mm-hmm.
Mm-hmm.
And then it goes on. If you finish reading it, it shows more evidence for, this looks like the stuff we find in bone today. And then it says in C, complete demineralization reveals transparent, flexible vessels in what remains of the cortical bone matrix, represented by a brown amorphous substance. Now that is in C, right? That's what it looks like in C. They say a brown amorphous substance. Don't know what it is yet because it hasn't been investigated. But it does look like you've got transparent, flexible vessels, which is really interesting. Now, the thing is, another point to make in regards to a lot of the creationists who look at this stuff is that they forget when they put this up, these legends up, that all of these pictures are not from a T-Rex. For example, in D, you notice what it says? Ostrich vessel after demineralization of cortical bone and suggested so on and so forth. So what they're doing is they're comparing what they're finding in the T-Rex with what you find today in an ostrich. And an ostrich is a pretty good choice because it's a big freaking bird. So it's the closest living thing we have, perhaps, to a T-Rex in terms of structure. So they're using an ostrich, and they use an ostrich in a lot of these. So D is ostrich. And this, you will see a lot of comparisons between T-Rex and the ostrich. And I have seen creationist websites that don't bother to tell you that some of the pictures are ostriches. And that's something to be aware. And sometimes it's simply because people, to support their point of view, are just copying and pasting. They may even be copying and pasting from a creationist website that does point out that's an ostrich. But when they go and copy and paste it, they leave off the legend. So that's in D, and it shows you again, it looks like this is an ostrich bone. And E is the higher magnification of dinosaur vessels. And again, F, T-Rex vessel fragment containing microstructures consistent in size and shape with those seen in the ostrich vessel in H. So you look at G and H. G, F and G and H. So F and G are dinosaur vessels. H is an ostrich vessel. That's a living bone, or it was taken from a living creature and then treated similarly because it was also demineralized, and it looks a lot alike, which is pretty cool.
Yeah.
And in I, again, here's another T-Wrestle fragment showing detail of branching pattern and structures morphologically consistent with endothelial cell nuclei with J. Ostrich blood vessel liberated from demineralized bone after treatment with collagenation. So what they're doing in these pictures is they're comparing, and what the ostrich, what you find from the T-Rex to the ostrich.
Can I point one thing out?
Sure.
If you don't read it really carefully, what you see is a sentence saying red blood cells can be seen inside the branching.
Yeah, I'll just speak about that. It was a H, a figure of H, because it says.
Yeah, it says an I.
Just from the muscle contact, red blood cells can be seen from the branching vessel.
If you look, it's saying H, ostrich vessel digested from demineralized cortical bone, full stop. Red blood cells can be seen inside the branching vessels, figure I. So they're coming from H, which is the ostrich, and they're showing you the red blood vessels from the ostrich in I.
Right.
Oh, so they're actually referring to I.
The I is referring to H as well, which is the ostrich vessels.
Right. It is the ostrich that actually has the red blood cells in it.
Yeah.
Yes.
Right. Gotcha.
So that can cause a lot of confusion. If you've got to read the legends to figures very carefully.
Yeah.
Right, but
and this is where you get the creationists saying they found red blood cells. No, the red blood cells are in the ostrich. We found round things in the dinosaur bone, but they haven't been identified yet, and they may just be remnants. But they're not living blood cells or recently dead blood cells.
Okay, but what I'd say to that, though, is number I is to T-Rex vessel fragments showing details of pattern and structure morphology consistent with endothelial cell nuclei arrows in vessel wall. Isn't endothelial cells, from what I understand, part of fragments of DNA? Or like skin fragments or something like that.
What it's saying is you're seeing the detail of a branching pattern and structures morphologically consistent with endothelial cell nuclei.
Okay.
So they're morphologically consistent with endothelial cell nuclei, but that isn't saying that they are endothelial cell nuclei.
Okay.
You're just saying
sorry, I'm just making my mistakes again, sorry.
Yeah, it's just that they have the same appearance as, so they're morphologically consistent with, but it doesn't say that they are.
Right, they look like them, in other words, Gary.
Okay,
they look like them.
So sorry, I'm just not used to reading something like this, sir.
No, that's fine. See, again, the questions you are asking are questions other people would ask, and it's good to get those out there. And endothelial cells are, weren't they like skin cells? What is the exact?
Endothelial cells are the cells that line blood vessels.
Oh, the blood vessels. Oh, okay, there you go.
See, the reason that I sort of know about them is because of CSI, and that's the reason I sort of know about them.
Right. So the endothelial cells, so basically what they're saying is this looks like it might have been a blood vessel.
Okay. So it's trying to make a cohesive point that the T-Rex microstructures have things that point to being comparative with ostrich vessels. Is that correct?
Yes.
Yeah.
But it's not saying that's what they are. It's just saying they're not inconsistent with it.
Right. Because you got to do a lot more investigation before you confirm this. As again, the scientific papers, they're careful in the wording they use. And so, this looks a lot like you have. It looks a lot like we have the evidence of the former existence of blood vessels in the Tyrannosaurus Rex.
Okay.
It doesn't say that's what they are. It says that's what it sure as heck looks like.
But Jade, I'm going to ask a question now. You're going to it's not because I'm a creationist. I'm just asking you. I'm going to be a full creationist just for the argument. Could they make an argument that this proves that the T-Rex was alive much more earlier than we thought, because we don't usually find these sort of structures in as far dead animal as T-Rexes are supposed to be? I mean, could they legitimately make that argument or not? I'm just asking just for the sake of answer. I'm not saying that I hold that position. I'm just asking.
Do you know, they could legitimately make that argument if they ignore all of the dating evidence of the Hell Creek Formation.
Okay. Well, how's
the actual dating of the rocks?
Formation? Sorry, that's another stupid question. Sorry. How's the Hell Creek Formation? Sorry, that's something that I don't know about. Sorry.
That's where they were found.
All right. No, but I mean, how old is that though? That's all I was asking.
It's 65 million years.
65 million years. Okay.
Yeah. To make the argument that this is genuinely only dead for a little while, they have to ignore all of the geology of the formation, all the radiometric dating methods that have been used to date that formation. And they also have to ignore the fact that not all of the bones within the Hell Creek Formation have actually shown this. This is why this is such a stunning paper. That's rare.
Well, I mean, the other thing is, I mean, this came out of a fossil, right? The bone was fossilized, and that is not a process that happens in a short amount of time anyway. That itself is a huge, long.
Well, yeah, there are creationists out there who do dismiss the radiometric data method. Again, and I'm not pointing that out because I am a creationist. I'm just pointing out there because that is true. That's what they do.
Well, you're a different kind of creationist.
I'm not a creationist.
Oh, you're not a creationist. Oh, no. Well, in a way you are.
Yeah, you are, just like me.
But you're not a young Earth. Yeah, you're not a young Earth creationist. That's a different, But yes, they could make that argument. The problem is they have to make the argument, an argument saying, well, we don't know any other way that these things could have formed is not much of an argument.
Yeah, but the other problem they have is this, that if they then take issue with the radiometric dating methods, they're then going to have to start saying that all of the radiometric dating methods are completely and utterly wrong to fit in with their pet theory. And when you start to look at the decay constants for various isotopes and all the rest of it, and then you take into account Einstein's wonderful equation, it means that they've got to start messing around with the speed of light. So it's if they want to make the argument that this is very young, the number of different fields of science that they then have to throw out to make that one argument,
it automatically discredits them.
Well, because Fiona, I've argued with creationists before on the idea of radiometric dating. Now, some of them have pointed to different scientists that I've never really heard of, just debunking certain, like potassium argon one.
Oh, Steve Exhaustion, the $6 million man. Yeah.
Because I got Steve Austin was thrown at me, and his apparently he did something on St. Helier, was it St. Helens?
No, St. Helens. That was a travesty. It was a deliberate, fraudulent attempt to discredit potassium argon dating. What he did was he took a sample from the growing dome. This was after the Mount St. Helens 1981 eruption. The dome started to reform. And he went up and he took a sample of dacite from that growing dome. Now, they knew it had erupted within the last 10 to 20 years. It had come out of the ground in that time. And the potassium argon dating method tells you when rock was last molten. He knew when it was last molten, 10 to 20 years. He submitted it for this radiometric dating test that is suitable only for rock at least 200,000 years old. But ideally they want it 2 million and above. Because the detection level of the instrument comes into play then. If it's very, very young rock, then the argon that you're trying to detect is present in such tiny quantities that it's within the range of error of your machine. It's the type of readings that you get from it are basically what you would get if there was zero argon present, okay?
Yeah.
And so he deliberately submitted it for a test that was unsuitable, knowing that it would give erroneous results. And the company who did it advertised on their website what the minimum age of the rock had to be for the method to return valid results, because the errors in younger rock were too great to rely on the data. Steve Austin knew all of this, and he went ahead and submitted the sample, and he didn't tell the lab where it was from. On top of that, one of the things you have to do is remove from your sample any minerals which would actually have been in a solid state at high temperature and pressure, i.e. solid crystals inside the magma. Olivine is one of those. So if it's already solidified before it erupts out, it would date as much older. Okay? So you must remove olivine from the sample. And he hadn't properly sorted his sample out to the datable material. So it was contaminated with older crystals. Because remember, the dating method is telling you when the rock solidified.
Mm-hmm.
So if you've got these olivine crystals that solidify while they're still inside the earth, you're going to get a much older date from those crystals. So you're not getting the date that it was erupted out anymore. And that's what Steve Austin did. He has been busted completely on this. Absolutely busted.
Oh yeah, people even contacted the lab. It was Geochron Lab, and they were not happy.
No, they were furious.
And they also no longer do potassium argon. As a matter of fact, most labs no longer do potassium argon. They use argon because it's more accurate.
Yeah. Okay.
The last thing though, Gary, is I want to say about that is, ironically, I did quite a bit of research on this. I've read all Dalrymple's books, and he's G. Brett Dalrymple, and he's an expert on potassium argon dating. And his books are really interesting, I think. And he talks about this, where you have inclusions in the rock that are older rock, and olivine, and that's what part of the problem is. But the other interesting thing is, when I looked at a lot of different potassium argon dates, and most of them have a probability range. When they give you a figure, there's a probability range of plus or minus 100,000 years to plus or minus 250,000 years, depending on the instruments used. Because the instruments are different, which is why in papers, scientists are very careful to list what instruments they've used and where they were, like what lab you sent things to. The irony is that if you look at the plus or minus 250,000 year range, guess what? The Mount St. Helens samples are fine.
Yeah.
So,
But those error bars were meaningless, because I think some of the data that they got, when you took those error bars into account, it actually put some of them into the minus age.
Yeah.
They were still to erupt.
Yeah.
You know, this is, and it's that sort of methodology that's cast doubt on radiometric dating, and it's dishonest methodology. But to get back to Gary's original question, to make the argument that this is all young, these are the sorts of things that the young Earth creationists have got up to.
Right.
They have actually tried to tackle radiometric dating. and show it's wrong. And they've also tried to say that the speed of light has been changing to take account of other things. They will actually go way outside that one field where they want to make a claim, because they have to change all the science surrounding it just to make that one claim stick.
Okay.
And then when they have to make another claim about something else, they will actually go out and change all the science again just for that next claim.
Right.
Yeah.
So which version of the science do you take?
Yeah, and I did quite a bit of investigation of that whole speed of light thing, and they've given that up for the most part.
Yeah.
There's only a few people. One of them is Matthew Bowden, and another guy who started it, Satterley. I'd have to look it up. I forget their names, but I did quite a bit of work into it.
Is it Setterton?
So, that was who it, yeah. But anyway, here's the funny part. I actually took his data. I went and downloaded his original data and graphed it myself. And I accepted his original data, but his original data isn't any good. But I won't even go into that. But I'm just even accepting his original data. I graphed it myself. And I went through this whole thing, and it was only until I went through the whole end of it, because what I discovered was, first of all, he left two of the most important dates of the speed of light off. Two of the most important measurements, which were by Fizeau and Foucault, two different men. Their measurements were not on his graph, which I found astonishing, because I looked into the history of this whole thing. I even found this guy who's a college professor in physics, who I now have on Twitter, because he's actually a really cool guy, who went and found the original French papers by Fizeau and Foucault, which I thought was pretty cool. I even have links to that now, just to verify the dates. And when I graphed the dates by Fizeau and Foucault on the graph that these guys used, they were one was way up off the graph on the top, one was way off the graph on the bottom. So no wonder they left off two of the most historically important dates, because it didn't fit their cute little graph.
Yeah.
But
Also,
then there's one more funny, because this is really funny, because I was stupid. When I looked up the data, it was like they were saying, well, gee, I don't remember which one it was, Fizeau or Foucault. Even for their primitive data, they were only like 4% off. And I'm like, what? Wait, it's 4% off, but it's way the hell off the graph. That's when I bothered to do something I should have done in the first place, which was to look at the freaking y-axis. Because what they did was they set up the y-axis in such a way as it exaggerated all their data. All of that data that shows the speed of light is showing is actually very close together.
yes.
But they exaggerated the y-axis.
Yeah.
It's a total fucking fake. And when I realized that, I was just like, you numbskull, you didn't bother to look at the measurements.
Yeah.
Who'd have thought? Who'd have thought creationists taking it out of context?
Yeah, if I could explain it, I'll use this, right?
Okay.
They say the speed of light's been decreasing, right? So, let me move. Can you see that weird thing? That would be the line on the graph. Decreasing, okay?
Right.
And they plot the graph, and the dots fell on that line, okay? When you look at their data, they'd plotted, I think it was 40 points. And they'd ignored another 150 that didn't fit on the line. So to get the straight line, they removed all of the points that didn't fit on the line.
Right.
And then claimed, look, it's a straight line. Texas sharpshooter fallacy. You shoot the barn door and then you go up and draw a target around the bullet hole.
Yeah.
That's exactly what they did to show that the speed of light was decreasing. And these are the things that they have to do to then use their explanations, whether it's to do with the age of the dinosaur bone or whatever. And it's an absolute nightmare, because it messes up absolutely everything we know. It means that when I calculated this to its logical conclusion once, to do with the radiometric dating of the rocks, and also how the speed of light would change that if the speed of light was decreasing, and what would be happening to natural isotopes. And the natural reactor in Oklo, which is a uranium mine, that would have gone critical because of E equals mc squared. c squared being the speed of light squared. If the speed of light was much, much, much faster, then you need an awful lot less mass to get the same amount of energy out.
Yeah.
Was mc squared.
Well,
So it would mean that way, way back, when they're claiming the speed of light was much faster, this planet would have melted.
Yeah.
Because it would have been a self-sustained nuclear criticality reaction going on within the Oklo reactor, but it would have run out of control. So rather than like being just a controlled self-sustaining reaction, it would have gone kablooey. And
Yep.
the Oklo reactor didn't go kablooey. The uranium deposits are still there.
well, gee, good thing I'm not in a trolley mood, because otherwise I would have just asked Fiona then. How does that prove that you can get from the antecedent live dwelling mammalian tetrapods? Sorry, I can't do it. I just can't.
Oh, you're trying to be a creationist?
Not trying to be Neffy. That's what I'm trying to be.
Yeah.
I'm trying to remember what exactly is the way that he asks that question, because I'm like, yowza.
Yeah.
Because I have been watching Fiona, and I should be upfront about this. I have been watching UV's Neffy, because I am trying to see if I can copy their style. And Neffy's like the one that I'm trying to copy, because, God's sake, I mean, he asks the same question, and when he's given an answer, he goes, "So you presume?" No. Well,
I know.
you know.
I know. It's
Sorry.
very
Okay,
hard.
carry on, Jane, sorry.
You said carry on just as I took a mouthful of M&Ms.
Sorry.
Listen, that's Gary psychically putting you on a diet. The psychic diet, that's all we need, isn't it?
Yeah, really.
Well, Jane knows that I love her, and that she's my big sister. So
Yeah.
But you're still getting in between her and her M&Ms.
I know. I'll forgive him.
Well, Jade's talking about coming to the UK, Fiona, and I've said to her that if she does, that I will take her out on the town.
Oh, yes.
I'm hoping to come. It's going to be about a year. I swallowed an M&M. Trying to talk and eat M&Ms, I swallowed an entire M&M.
That's a waste.
Yeah. Well, I have a whole bunch of them. I got
It's
them on
okay,
sale.
you can retrieve it tomorrow.
Yeah, really. Oh dear. Yeah, because I want to spend some time there. So it's going to be a little while because I've got a lot of stuff to do at my house, and there are some other complications. Like with Brian in exile, perhaps. So, well, one of the interesting things is too, if you go to like Conservapedia, they don't believe in E equals MC squared.
Yeah.
Oh, dear.
Yeah, and
how bad it gets in their denial to try and work out that the age of the Earth is young, because they are trying to dabble in, well, they have to dabble in nuclear physics.
Mm-hmm.
So although we're talking about this dinosaur in the Hill Creek Formation and we're talking about soft tissue and all the rest of it, when you get to trying to change the age of it, you are going way out in the other areas of science. If E equals MC squared doesn't hold, then do you want to go and tell the people of Hiroshima that? Because they'll tell you that it does.
Yep. And the thing that is that if you really want to believe in a young Earth, if you want to take Genesis literally, fine, go for it. I don't care. However, don't try to destroy science. Just simply say, honestly, and I have had people honestly say this, don't know how God did it. I don't know why the dinosaurs seem that old. I believe in a 6,000-year-old Earth. I don't know if God created the Earth fully formed with the dinosaurs in the ground for some reason. I don't know if maybe God sped up certain processes to cause this thing to happen. I just simply don't know. That's an honest point of view.
Yes.
The part that's not honest is when you do realize we're now reading your mail, Char, which is fine.
Let's just There's nothing.
Yeah, I know, that
we
was
did.
funny.
We were looking for the scandal.
There are no secrets. There are really no secrets in Cogito. Yeah, we just wish Fiona was on Skype so we could add her to Cogito so she could enjoy all the fun.
Oh, listen, I'm now on Skype. I've got the laptop fired up and running.
You'll have to send us your Skype. Yeah.
I have no idea what it is. I'm still trying to log in.
Okay. when you do, let us know.
Yeah, I'm actually getting the other night there. I spoke to DPR Jones on Skype. So
Wow, how cool.
I should be able to get it going.
Yeah.
Well, yeah.
But yeah,
we're
so
much
like I
nicer
said,
than DPR Jones is.
the two things is stop making these stupid arguments about science because you're failing,
Mm-hmm.
and don't try to get creationism in schools as science.
Well,
Yes.
I've always pointed out
that
that
Wikipedia, the site that. Sorry, Jade.
I was just going to.
Is Wikipedia the site that Josh Shelley gets his information from?
I don't know where he gets his information from. I hate
Because
to
apparently
speculate.
the book that he has or had
Yeah.
was like a lot of stuff cut and pasted from Wikipedia.
He was whining and yeah. He was whining in Facebook recently because apparently he got kicked out of a group.
Oh God, which one?
I don't remember. I'll have to look it up. I don't remember which one it was.
Science, was it?
He's been posting in the battlefield again, or I think the battle. I don't remember.
Sick.
And I just ignore everything. I just ignore his posts, and I've noticed a lot of other people do too.
Yeah, I don't get near the battlefield.
Yeah. But yeah, it gets really tiring because the people keep bringing up the same stuff over and over and over again, and doesn't make any difference what information you get them. This is the problem with creationism. But if you want to teach a class in school that talks about Christianity's role in Western civilization or something like that, then you can teach old Earth creationism, but don't teach it in a science class. There's no evidence for young Earth creationism. Sorry.
Oh yeah, yeah. I mean, as long as you're not saying it's science.
Right.
Because I mean, I wouldn't like if my son was going to a metalwork class and came home with a recipe for fairy cakes.
Yeah, really.
That would be something that you would think, no, this isn't what he's there to learn.
Right.
Yeah, well, I was just going to say, Rhoda, have Tommy Hall's put out 2 videos where he has sock puppets talking about creationism?
I haven't watched.
No, I haven't. I watched a little bit of the first one and thought this is horrible, and I left. Yeah, I couldn't watch it.
Yeah, I couldn't. I just haven't been able to bring myself to click on the links.
Mm-hmm. Oh, I just want to say this.
It is hurting me to just look at them.
Yeah. While I'm thinking of it, I wanted to point out that I'm going back to school again in a couple of weeks, and I'm taking a class from UC Berkeley. It's online, but it's a regular college class. It's not extension or anything. It's a regular college class. And just, Fiona, you want to guess what class it is?
Go on, tell me.
Molecular
Come
biology.
on. Yes!
Molecular biology.
We are a people!
So,
We are the champions, my friend. Sorry.
So yeah, I'll be, and after that,
Fiona,
I'm
are
gonna
you
take
drunk
a class
in
in
Are
genetics.
you drunk in a hangout again, Fiona?
Yeah.
I wish I was.
I just had to tell you that because that's going to be my first class is molecular biology.
Excellent. That
and
is
then I'm
excellent.
going to be taking a class in genetics, and because I'm getting back to going to school, I found these online classes and they're regular university credit. So I thought, well, that's a good way to do it because I'm really good at learning by myself.
Yeah.
And then when I start getting back into the hang of studying, then I can just go to a regular, probably UC Santa Cruz or something. But yeah, so I've decided to go back and get my degrees. Because why not? But yeah, I just had to tell you that my first class in molecular biology. So if you get any questions, Fiona.
Yeah. I know why. I've got into my scalp.
Well, Fiona, the thing is that before we went online, I was sort of defending true empiricism use of specified sequential information.
Why were you doing that?
Why was I doing that? Because I have heard it used by somebody who doesn't agree with the way that true criticism uses it.
Mm-hmm.
Because I heard Richard Dawkins use it in a way that when a change happens in a particular genome, we can sequence that particular change, and that's the way he was using it, from what I understand.
You see, I think the problem is the fact that he used specified when he meant specific.
Okay. Yeah, I think he meant specific.
Yeah. If he said it was sequential specific, you know, for a given gene to make a given specific, as in that will only make that one protein, then that'd be fine. But he said specified. And when asked for, well, what do you mean by specified? He said, well, the amino acid sequence of a protein is specified by the nucleotide sequence on the RNA. And the nucleotide sequence on the RNA is specified by the nucleotide sequence on the DNA. And I said, that's brilliant. But you said it was the DNA that was specified. And using the word specified in the way he was using it, talking about the amino acid sequence and the RNA sequence, it makes no sense on the DNA.
Yeah.
See what I mean? It's like if I use an equation and I plug in certain values to the equation, I will get out a specific answer. Okay? And if I put in different values, I'll get out a different answer, but it's still going to be specific. But it's not specified. Because it doesn't matter what numbers I put in, I'm always going to get out a specific answer. And they'll be different if the inputs are different. Do you see what I mean?
Yeah.
That's the difference between specified and specific. They're different words completely. They mean different things.
Yeah.
Mm-hmm.
That's where the problem lies. And in fact, in a hangout, Arcane actually admitted that, well, what he said was, well, if I was to say that, yeah, Ronnie did misspeak.
Mm.
And Arcane was making the argument using the word specific. And it's at that point, I don't take any issue. I'm taking issue with specified. Because if it's specified, something must have done the specifying.
Yeah. It has to be an agency in there.
Mm-hmm.
Yeah. And that's the problem. So there's no point in showing that the DNA specifies the RNA and the RNA specifies the protein if your claim is that the DNA is specified, because none of what you've said is evidence that the DNA is specified. You've just given me evidence that it is specifying.
Well, I had pointed out before that Hogtie was trying to explain something to him, which didn't work because he wouldn't listen, but Hogtie later kind of spelled it out in a comment. He was trying to say to Ronnie, he was going, okay, I have a deck of cards in my desk.
Yeah.
You know, and his point, which he was never able to get through, because even when G-Man even interrupted and say, well, use the alphabet. The point that Hogtie was trying to make is the deck of cards in his desk had already been thoroughly shuffled. Okay. So the cards were in a sequence. That's not a problem.
Yeah.
However, he didn't know what order they were, and they weren't in any specific order, so they weren't. It was, and you could call them information. Fine, the cards are information. We know that each one says something to us. So they weren't in a specified order because it wasn't determined. It wasn't an order that was previously determined, but they were in a specific order, even though he didn't know what the order is. So there's a difference between the words specific and specified. And as I told Gary, one of the big problems with Ronnie, true empiricism, is that you could never get him to explain exactly what he meant or to understand the difference between specified and specific.
Yeah, I mean the thing with Ronnie is that I
I think there's a lot of redundant questions here because he either does not understand
what he actually means in his own argument, which is perfectly plausible, or he just is willfully not making sense. Either way, it's kind of a redundant question as to what he means. He's just so willfully dishonest that I don't see why anyone gives anything the man says any kind of credence. It makes no sense to me at all.
No. Gary, give us your Skype address. And I'll try and add you. Type it into the wee side chat. I've put mine in the side chat, see if you can send me a thingy. I've not used it for so long. Oh.
Okay, I've given you mine because there are a number of Fiona Robertsons on Skype.
Yeah.
Let me look at yours, Gary, to make sure, see which name you're under. That should be mine, I think.
Let me
At least when I look at my account, that's the name of my account.
Got you.
You got it? Okay.
I got you. Yep. I think I have. It's a very strange.
Well, if you break that out, that's Meleagris felis. Meleagris is the genus of turkeys. Okay, let me see.
And Gary.
Okay. Oh, here. Well, that's not it. Yeah, Fiona Robertson. Got it.
Yeah. Could you believe I actually forgot that was my Skype name?
Yes, I could believe that. I could believe that because it happened to me the other week.
Yeah.
Yeah.
It's sad, isn't it? You forget your own name.
Yeah.
Let's see if we get.
Cool.
Found them.
Got it. Good.
Yep. Right.
Well, yeah. Nobody can remember my Skype name or it's my name. It's my channel name too because it's Meleagris felis, which simply means turkey cat.
Yep.
It's the genus of turkeys and the genus of cats.
I like that name.
It's easy.
Yeah, my problem is that for my login username is a ridiculous one. It automatically gave it to me, and it's this huge big long line of digits. Useless, absolutely useless. But there we go. I've sent a request to Gary.
Okay, cool.
Gary walked away, or is he hiding under the desk?
It's probably hiding under the desk.
Oh well, he runs into Mummageddon late at night, so
that's right. Yeah.
Well, anyway, basically, I think we're kind of done with this paper. I mean, there's more to it, and people can read it for themselves. But we got to the points that we wanted to cover. At least I wanted to cover, about the pictures, basically. But the next one, the one that I really wanted, where is it? Let me close that. Is this the one?
And we'll get Shar to share it.
Yes, here we go. Let me put this one down for Shar. This is the one I really wanted Fiona for because the title is Biomolecular Characterization and Protein Sequences of the Campanian Hadrosaur, B. canadiensis.
Right, okay.
Okay, just, we're getting into stuff. Oh, you got it. Okay, good. There we go. Because I think we're getting into stuff that talks more about things that Fiona would know a lot more about than us.
Okay.
In my case, that's quite a long list, in fairness.
Yes, that is quite a long list.
Oh.
So, yeah, if you want me to read it or somebody else want to read it? Because we could take.
Can you give me a minute to get a call? I'm going to need caffeine to do this.
Yeah.
Okay, go ahead. Yeah, go get some
caffeine because I've been really not well all day.
Oh, I hope you feel better. I mean, yeah.
So do I. This is getting ridiculous.
Science makes you better.
Yeah.
Metaphorically and
side chat here.
Yeah. Yeah, no hurry. But the minute I saw biomolecular and protein sequences, I thought Fiona.
Yeah, picking me, why don't you? Right, I'm muting myself.
Okay. Ouch.
Oh, quiet.
I know. We do occasionally get quiet. It's hard to believe, you know. But
Terrifying, isn't it?
I know it really is. So Gary, do you have any, or anybody have any questions? Gary, you can type in them if you have any questions. I can answer some stuff because I've spent 40 years actually reading creationist literature, which is a long time. Now, and when I was younger, I didn't read it as much as I do now, and I have quite the collection of creationist literature. And I do know some science stuff, but I'm woefully lacking in a lot of ways. So if anybody has any questions, you can ask or type, and I'll do my best to answer.
I do have an interesting thing to add on the, you know, like the creationist claim that speed of light has changed. I watched an amazing creationist lecture once, like maybe a year ago now, where, you know, like how the Bible describes a canopy, a water canopy, like in the sky.
Yeah.
Yes.
Well, he said that canopy is actually still there and it surrounds our universe, and that it's a whole lot of gravitational pull that sped up the speed of light or something like that. I don't know. It didn't actually make sense.
Of course, it's creationism.
But the imagery was rather so. Yeah. So like on the outskirts of our the universe, there's this big shell.
Oh, I think I know what you're talking about. Yes,
water. Yeah. I didn't understand it at all, but it was
Okay.
It was fun to listen to.
Well, one of the problems they have is if there was a great flood, and that's the other thing. The two big arguments that they bring up are, you know, Genesis and the flood. If there was a great flood, and if you look at the description, and they look at it literally rather than figuratively, of course, the waters of the you know, not only did we have this huge rain from above, but the pillars of the earth opened up. Anyway, we got all this water from under the earth. But one of the problems we have is there isn't enough water on Earth to have covered the entire Earth. So one of the things they say is, well, the thing is the Earth was flatter then. So, if the Earth is flat, not only that, the creationists have adopted the concept of Pangea, which they rejected for a very, very long time. So the thing is, there's this one continent. Now, again, this isn't all creationists, it's some of them. And some young Earth creationists, let me be clear. There are a lot of theistic creationists, who, like Gary and Fiona, who believe that God had some part in it somewhere way back in the beginning, but, you know, hasn't fiddled around, basically set things in motion, and then it keeps going, okay, which is fine. So there was one continent, okay, and it was really flat, which is why you could have enough water cover it. Now, where all that, I guess it must have been a bigger continent, because I actually haven't figured this out, I wonder if anyone has. If you flattened out everything on Earth, how big would that continent be? That's an interesting question. I haven't seen that answered. So anyway, there was one big continent that was really flat, okay? So it didn't take as much water to cover it. And that is one of their explanations for why all the figures that people have done have said there isn't enough water in or on the Earth to have covered it. Okay. So their excuses are, well, we had water come down from the heavens, as well as water from under the earth, and the continent was flat, so we had a lot more water, and we didn't need as much water. So the next two questions are, as I said, I have not seen any figures on how big that new continent would be if you flattened the whole freaking earth out. Where did the water go afterwards?
Exactly.
Did the water that came up from the ground go back into the ground? Where did it go? Because we don't see that water now. Recently, they have found evidence of hydrates in rock. It's a ringwoodite or ringwoodite. Oh, I always get it wrong. I'm sorry. Deep into the earth. Now, so far, there's only been one research project that has found this, and it's only found it in one location. That doesn't mean that research isn't any good. All it means is this is really cool, and they intend to do more research.
Because it's one example, it doesn't prove anything necessarily.
No, and ringwoodite, or I hope I have it right, because I'm always misstating that, and then I look it up and go, oh, you did it again, Jade. Has up until now only been found in either comets or meteorites or something like that, but it hasn't been found on Earth. Well, the thing is, it doesn't have water in it. It has hydrates in it. It has chemical compounds from which, under certain circumstances, you could get water. Okay. And I don't even know what percentage of the rock is hydrates. The problem is that a lot of the news media, they, you know how they always put something inflammatory as a title. They go, giant ocean of water found under the earth near the mantle.
Yeah.
No, there's no ocean. There's no water. There are hydrates in rock. But so the creationists now are trying to say, well, that's where the water went down into the earth. But they still have a problem with where the water went.
Yeah.
So the other thing is the water had to go up into the atmosphere somehow. So where did it go? Because we can't see it. We don't see any water up there anywhere. So what Shar is talking about is some people have decided that, yeah, the water's there. We can't see it because it's further out. It's like surrounding the universe, or it's, you know, way out there somewhere.
Yeah.
Actually, I actually heard another creationist who came to our university once, and actually this theory, while it's ridiculous, almost sounded not bad. And the idea was that the crust of the Earth is quite plastic in places because it's quite thin, right? Mm-hmm. And so because there was supposedly a wind or something that passed by the Earth, like before the flood, they said it was a comet, and that the comet was big enough that it caused a great gravitational pull that pulled up the floors of the ocean and pushed the water onto the land.
No.
Well, that's an interesting theory. I'd like to see the calculations that made that happen.
There weren't any calculations per se, but it is an interesting theory.
Right.
I don't know where the magma goes. I don't know how the magma and the core of the Earth and everything survived that sort of, but yeah.
Yeah, and just the Earth itself. I mean, it would have ripped the Earth apart, I would think.
Yeah, but it's creative though. I'll give them that.
So. I would have thought that it would have caused enough disruption on the Earth's surface that we would see evidence of that, but we don't.
Yeah.
I'm getting ready.
The last part about the giant continent theory, you know, their version of Pangea, is that it was the flood that caused all the continents to split apart, and it started during the flood, and that's why we now see all the different animals in different areas. Apparently, after the flood and the animals were unloaded, they all went to their designated areas, which then split up.
Well, it's an improvement on the it's an improvement on the volcanic ballistic kangaroos.
Oh, I love that one.
All these koala bears and kangaroos being blasted by a volcano.
Well, I came up with my own theory because I've often said that I could argue creationism better than creationists, because if God is doing everything, you know, God can do everything. My theory is God just ordered to take everybody to Australia.
Yeah.
They rode whaleback. That was my theory. I mean, you know, why not? It's better than theirs.
Seems legit.
They're trying to rip the earth apart. My point of view is, well, if God can have all the animals come to one central location so they can be loaded on the ark. Afterwards, God can designate where they can go. And hey, you know, whaleback. You know, you've got the koalas and the kangaroos and everything. They're just riding whaleback to Australia. What's the problem? I don't get it.
You see, this is when I run into real problems, because where did Noah keep the woodworm?
Yeah.
And there's a brilliant cartoon, and it's all the animals and Mr. and Mrs. Noah peering over the side of the ark, and perched on the outside is this woodpecker, and Mrs. Noah saying, "I'm sorry, Mr. Noah, but that woodpecker's got to go." And then that raises another question for me, is this: are ants clean or unclean?
I don't know.
Because if we only took 2 ants and the anteater got one.
Yeah.
Yeah, I know.
Well, I want to know what he did with amoebas.
Well, my
animals came in two by two. No, 4, no 8, no 16. No.
Yeah, but what about Kent Hovind insisted there was fire-breathing dragons on the ark?
I know. Yeah, right, on a wooden boat.
People saw them in China. Did you know that?
Like that again.
Marco Polo saw fire-breathing dragons in China, according to Kent Hovind.
Right.
Therefore, there must have been fire-breathing dragons on the Ark. Now, you put all those animals in a sealed wooden boat for that length of time. Can you imagine the methane build-up?
Yeah.
One
Yeah.
pick up from the dragon, and you've got Ark soup
Yeah.
Right.
with some
Now-
matchsticks thrown in.
Now you see
It-
my yeah. I was going to say my creationist version. When I don't know, if you've got God involved in this, why don't you use God as your explanation?
Just say God did it.
Yeah,
Yeah.
well, you don't even have to. Yeah, you could say, okay, my creationist version is very simple. God told all the animals or the appropriate animals to get to the ark in time. They gave birth so that they could take babies onto the ark, and then God put them all to sleep until it was over with. They didn't have
Yeah.
to worry about feeding them. They didn't have to worry about poop and pee. God
Yeah,
just
and then
put them
once they
all to
all got
sleep.
off, God wiped out all the evidence of the flood. I would
Yeah.
have more respect for that than I have for the attempts at using science.
Yeah, I would too. You could just say, we don't know why the layers look the way they do. God
Well-
put them that way for some reason, and we just haven't discovered it yet. That's an honest reaction.
Yeah.
Yeah.
Actually, I've never heard a creationist defend every single thing with science. Creationists will say things to the effect of, well, God created the earth with age built in, with the illusion of age. Well, if he did that, why can't you just accept that God did miracles of all of this stuff? Like, why explain some of it with science and not all of it? I don't get that.
Yeah, it's that inconsistency that annoys me.
Yeah.
I
Yeah.
think that's a big problem. Right, so but back to this paper.
Okay, so
No,
let's. Who wants to read it?
Okay, I'll read out. Do you want me to read the abstract?
Yeah, and you can tell
Okay.
us what it means.
Molecular preservation in non-avian dinosaurs is controversial. I'm reading it on the screen, so Shar, keep it still.
I will.
We present multiple lines of evidence that endogenous proteinaceous material is preserved in bone fragments and soft tissue from an 80 million year old Campanian hadrosaur, Brachiosaurus. Good grief. Canadiensis, Museum of the Rockies, MOR 2598. Microstructural and immunological data are consistent with preservation of multiple bone matrix and vessel proteins, and phylogenetic analyses of Brachiosaurus
Brachiosaurus.
collagen sequenced by mass spectrometry robustly support the bird dinosaur clade, consistent with an endogenous source for these collagen peptides. These data complement earlier results from Tyrannosaurus rex MOR 1125 and confirm that molecular preservation in the Cretaceous dinosaurs is not a unique event. I have no idea what it means because I'm too busy concentrating on that one bloody word. Oh, I hate that. Words like that are just not in my field.
Brachiosaurus. Brachiosaurus. Yeah. Canadiensis, which basically means
yeah. So here we are. So they're looking at molecular preservation, okay, in non-avian dinosaurs, as in old dinosaurs, okay. And this paper is giving evidence that there are some protein-based material being preserved in bone fragments and in soft tissue, as they're calling it, okay? And they're saying that they did this using microstructural methods and immunological methods, okay?
Okay.
And also it's going to get into which antibodies worked, as in your avian antibodies, etc. So that's what that bit's saying, and it supports, the data is going to support the idea that the birds and the dinosaurs are in the one clade, that they are related.
Sure.
Okay?
Yeah.
And could I just add, what's important about this particular paper is in the very first line, this is a non-avian dinosaur.
Mm-hmm.
Yeah.
So this is what this is basically saying is, we have the more avian type dinosaurs. This is a non-avian dinosaur, and it basically supports that dinosaurs do belong to the same clade, the non-avian dinosaurs and the avian dinosaurs.
Yes.
Right.
Hold on.
Okay. Do you want me to read or?
I'm looking up a picture of this damn thing I can't pronounce.
Oh, okay. Yeah.
Oh, it's an ugly thing. I don't want to pronounce it anyway.
This is a duck-billed dinosaur, isn't it?
Let me see.
Let me see if I can find I think a hadrosaur.
It's a strange-looking thing. It's got a bony crest. It's got a flat paddle-like plate at the top of the skull.
Yes, yeah, hadrosaurs are duck-billed dinosaurs.
Basically.
Mm-hmm.
Brachiosaurus.
Yeah, these are what are casually called the duck-billed dinosaurs, hadrosaurs.
Yes, I'm just looking at a skull.
And there's a whole wide variety of them. They're really interesting.
Yeah.
And if you see a picture of them, you'll notice they do not, they're quadrupeds.
Yes, they are.
Oh, yes.
Yeah, although I'm not sure if they're complete quadrupeds or not. Let me look.
You might not necessarily know, of course.
Their
Yeah,
front
that'd be
feet look
difficult to-
kind of hoof-like, though. Don't really look.
Very strange looking creature.
There's what's known as a facultative
Facultative.
Yeah, I can't say. Quadruped.
Yep. So it could go on 2 or 4.
Right, and those are animals. Yeah, they can walk on 4 legs. I mean, they are normally 2-legged, but they can walk on 4 legs. One of the things that has happened with dinosaurs is you're constantly discovering that things aren't exactly the way they thought they were. Yeah. There we go. Oh, I remember them finding Leonardo because that was so cool because it's actually mummified. Yeah.
Isn't that a Teenage Mutant Ninja Turtle?
I know.
Yes. Showing my age here,
Yeah.
or at least my generation.
Mm-hmm.
Wow.
Which is why I like it when science does things like call things sonic hedgehogs.
Yes.
Oh,
yes.
yeah.
Oh yeah. There's one called
Pronounce
Cheap
that.
Date. There's one called Cheap Date because it's intolerant to alcohol.
My favorite is when it does it unintentionally though. There's a mineral called Welshite because it was found in Wales.
Oh.
Yeah. What's that you got in your hand? That's Welshite.
Welshite.
I love it. Listen, just looking at this, and this is completely off topic, but just looking at the picture for this ridiculously named thing that I'm just going to call Bill. Yeah, it's easy.
There you
But
go.
it says this. In 2003, evidence of tumours, including hemangiomas, desmoplastic fibroma, metastatic cancer, and osteoblastoma, was discovered in fossilised Bill skeletons. Rothschild et al. Tested dinosaur vertebrae for tumours using computerised tomography and fluoroscope screening. Several other hadrosaurids, including Edmontosaurus, Gilmoriosaurus, and Bactrosaurus, also tested positive. Although more than 10,000 fossils were examined in this manner, the tumours were limited to Bill and close related genera.
Well.
The tumours may have been caused by environmental factors or genetic propensity.
Mm-hmm.
That's an interesting wee tidbit.
That's one for the NCIS cold case or whatever it is.
No, it's a really, it's a really interesting one, that, because it's one of those wee bits of information that you squirrel away in the back of your head, and a couple of years down the line you'll hear something and you'll think, of course.
Yes.
So there you are, Bill. Call him Bill.
Okay. Bill,
Right,
I like
sorry,
that.
on you go.
Yeah.
Right, so where are we? Soft tissue.
Okay, soft tissue, cell-like structures observed.
Yeah.
Yeah.
Okay. And so the cell-like structures identified but fossils, raising the question of whether and to what extent original molecular components remain associated with these structures and the bones containing them. A suite of experiments supported the presence of original collagen molecules in the bony matrix of Tyrannosaurus rex, and phylogenetic analysis of tryptic fragments sequenced by mass spectrometry placed T-Rex within. Scroll down.
There you go.
Placed T-Rex within Archosauria, closer to birds than other vertebrate taxa in the sample database. 6. That's the reference.
Yep.
Deep burial in sandstone seems to favour exceptional preservation. We recovered a single femur from an articulated hind limb of Bill. The pes elements, tibia and fibula, were collected in 2006. The femur was untouched and protected under 7 metres of Judith River Formation sandstone in Montana until recovered in 2007. The femur was not exposed in the field, but jacketed with 10 to 12 metres of sediments to maintain equilibrium. Immediately after opening the jacket, bone and sediment samples were collected with sterile instruments, wrapped in layers of foil and placed in sealed jars with desiccated crystals until laboratory analyses were performed.
Right.
Okay. So they've taken every precaution they could. Bone and or process samples were dispersed to multiple institutions for independent analyses. Some bone fragments were subjected to chemical extraction and others were demineralized, showing marked preservation of microstructures resembling the soft transparent vessels, cells and fibrous matrix in this pristine bone.
Can I just back up a minute just to clarify something? When it says, oh, you just scrolled down, Shah. So I'm
Sorry.
Just,
There you
it's
go.
not, no, you're fine. I can still find it, but
She's useless, isn't she?
It's laggy.
no, it's pes elements. What does that mean? They're talking about the pes elements, tibia and fibula.
I'm going to check that because I wondered that myself.
What are pes elements?
It's something I can pronounce.
Yeah, yeah.
Right. I think it's going to be part of the structure. I'm not getting anything for that.
Well, because without seeing it in lowercase, it would seem that it would be an acronym of some sort, but
No, it's not.
but it doesn't appear to be.
Let me see. Foot.
Say again.
Foot.
Oh. Okay.
As in pedal.
Yes. I suppose so.
That is it. Foot.
Yeah.
Is he
Yeah.
bloody scientist in the terminology?
That makes sense.
Yeah. I
So
should have.
yeah, it's the foot elements. The bits of the foot.
Right.
Right, so let's get down to some of the. Right, you want me to keep reading?
Yeah, or unless you want someone else to. I mean, I'll read if nobody wants to, but
Yeah.
whatever.
But I think Sharon need to make it a bit bigger because I mean I don't know about you, but I can't see that. It's too wee.
Yeah. You can make the PDF a little bit larger to see, Shar. If by nothing else, I think just hitting Control plus. Oh yeah, that works.
I still just got a blush almost.
Did you were you able to make it larger, Shar?
Well, it's still tiny.
Do you want me to read it? Because she's muted, so she may be away from
Oh,
the...
okay.
Oh yeah.
Yeah, no, you can go ahead and read it if you want. But yeah, Shar,
Yeah.
when Shar gets on, she should be able
I'm
to.
here.
All right.
Okay, can you make that larger?
Yeah.
If you just hit Control plus, it should make it larger.
Like that?
No, that's
No, that went the
small.
wrong way. Control
Ah,
plus.
there
There
you
we
go.
go.
Right.
It's just
I think we
slow.
got to under
There we go.
field emission.
Yeah.
Underfield emission, scanning electron microscopy. Demineralized bone matrix was fibrous with fibers arranged either in distinct layers at approximately 30 degrees that retain the original plywood-like orientation of collagen fibers in bone or arranged in parallel. Microstructures with filipodial extensions extensions and internal contents consistent in size and morphology to vertebrate osteocytes. Oh, it's close. Were visible at matrix layer boundaries, referencing Figure 1A. The matrix was virtually indistinguishable from recent demineralized ostrich bone, imaged under the same parameters. In transmitted light, demineralized matrix appeared white and fibrous, and autofluorescized illuminated with a mercury lamp similar to extant bone collagen. Transparent flexible vessels were observed. Some contained spherical microstructures, whereas others contained an amorphous red substance that is superficially similar to degraded blood products in vessels recovered from extant bone. And I would like to put a big red ring round superficially.
Yes.
Being a layperson, but even I can see that.
Yeah.
So Candensis vessels were. Oh, so you've just moved it, so I'm just finding a place. There you are. Condensis vessels were hollow, with walls of uniform thickness, and possessed a surface texture that differed from exterior to luminal surfaces. Features not consistent with the relatively amorphous texture of biofilm (7). Vessel surface texture differed substantially from the fibrous matrix, but was similar to that seen in extant ostrich vessels.
Right, scroll down.
Scroll down for me. I'm picking up your Scottish accent here, Fiona. You are. I'm terrible at that. It happens.
Oh, this could be fun then. Ooh, we went up there.
It was after demineralization and collagenase.
Right, there you go.
Oh, you've moved again.
No, it's catching up.
Oh, okay.
Is it there?
No, it's got to go down.
No, it's this here.
No, it's after demineralization and collagenase digestion, osteocytes. There we go.
It's down near the bottom. It's down near the bottom of the paper.
It's a third column.
No,
so there's
this.
this.
No, it's still in the middle column.
I was still in the middle column.
There we go.
Oh, okay.
It was just this.
Right, it's right at the bottom. Oh, okay. So take it back up. After demineralization and collagen, scroll it back up. Now I know where you are.
Yeah, right it is. That's right.
Not that far up.
Right there. It's just slow. It's so laggy.
Yeah, no problem. So osteocytes were closely associated with vessels in both extant and B. canadensis samples. The variation in texture, microstructure, and color of dinosaur material is consistent with extant tissues and not plausibly explained by biofilm. Ovoid red cells, in inverted commas, with long filopodia similar in morphology to extant osteocytes were embedded in or associated with white matrix, figures 1J and figure S1, or vessels, figure 1H. In some cases, these were attached by their filopodia to adjacent cells, forming an interconnecting network as in extant bone. The cells contain internal microstructures suggestive of nuclei. I should say at this point, if anyone wants to stop me at any point and point something out, then please do so.
Oh, no, we're enjoying this.
I wanted to say is that extant means living. There are things that are extinct and extant. Extinct are the things that no longer exist. That are extant are things that still exist. So when they're saying extant, they're referring to the ostrich.
Yeah. Red filopodia extended from cell bodies into the white fibrous matrix, reflecting original chemical differences at submicron levels between cells and matrix, and inconsistent with recent microbial invasion. Under, I hate reading acronyms. I can never get my head around them. Under FESEM, B. canadensis, osteocytes and filopodia are similar in morphology, surface texture, and size to extant osteocytes isolated from bone digest. Can I just ask what that acronym actually stands for?
I'm just going to look for.
One of the things I'd like to say while that's being looked up is, you notice they have said twice that what they're looking at is inconsistent with biofilm.
Yes.
Mm-hmm.
Is inconsistent with recent microbial invasion. So what this points to this actually belonging to the hadrosaur.
Yes.
Right.
Hold on, I'm just pulling this up.
Yeah,
Because it's going to be somewhere in here.
I've got the wrong paper there. I've got the paper up too. And the link is 10. What does it say in 10? Just to see what that says. Oh, it's just materials and methods that are available supporting material on Science Online.
Yeah, I'm just looking for the...
yeah, I don't know what that means either.
I'm going to find out, don't you worry, so that we know. It's field emission scanning electron microscopy.
Okay.
Ah,
I
okay.
mentioned it earlier on. It's always mentioned first before an acronym is just used on its own.
Yeah.
Yeah.
Field emission
I just didn't
scanning.
think that's where it was.
Yeah.
Yeah. Okay. Sorry, I'm massive with these long words, by the way.
Well, does somebody else want to go on now and give them a break?
Yeah, I'll give him a break. We're at MOR 2598, right?
Yep.
Mm-hmm.
Okay, and I'm going to be reading from not from the screen, so I'm not going to worry about it. Sorry, but to keep up for everybody else. MOR 2598 bone fragments were chemically extracted for use in multiple analyses. Electrophoretic separation revealed a smear of silver stainable material not present in either buffer controls or surrounding sediment extracted in tandem with the bone. A dark staining high molecular weight band was consistently seen in guanidine extracts, whereas a low molecular weight smear was visible in trichloroacetic acid extractions. Now, and what they set up above is they said the bone fragments revealed a smear not present in either buffer controls or surrounding sediment. So again, it's pointing to it's from the dinosaur. Okay. Both chemical extracts and demineralized dinosaur tissues showed binding of antibodies raised against collagen and other extant proteins. Enzyme-linked immunosorbent assays and immunoblots of bone extracts showed positive reactivity to antibodies raised against avian collagen and or osteocalcin. Controls of extraction buffers alone or co-extracted sediments were non-reactive. Results were repeated in two separate laboratories on separate extractions of MOR 2598 bone fragments. So that paragraph is again saying, looks like it comes from the hadrosaur. In situ immunohistochemical analyses conducted on demineralized dinosaur extracellular matrix showed positive reactivity to polyclonal antibodies raised against avian collagen. Collagen, osteocalcin, and ostrich whole bone extracts, but monoclonal antibodies raised against a specific osteocalcin epitope showed no binding. This may indicate that the single epitope targeted by the monoclonal antibody was either not preserved or not present originally in Bill. Negative controls of secondary antibody only, no primary added, showed no binding, and specificity controls of inhibition blocking antibody sites by first incubating with excess collagen, see figure 2b, and tissue digestion with collagenase before antibody exposure resulted in the reduction of binding. Antibodies to ostrich whole bone extracts bound dinosaur tissue slightly stronger than commercial chicken collagen antibodies, possibly indicating more shared epitopes between bill and ostrich bone proteins than this dinosaur and chicken. These results support the hypothesis that original epitopes of bone proteins are preserved in these 80-million-year-old dinosaur skeletal elements. And that's very interesting because it does show a reaction. So what they're basically saying is, even though they're not seeing, I think, I'd have to reread it again, even though they're not seeing some of these epitopes, which they thought they might see, they are getting reactions to ostrich, even though they're not to chicken.
Right.
I need to read that bit back again to myself.
Yeah. Let's give Fiona a chance to read it back. She can help.
Right, okay. So, to begin with, right, we go to the monoclonal bit, and they didn't get a reaction. If you imagine a protein molecule, it's quite a big molecule, and if you raise antibodies against it, basically you expose an animal to the protein. and various parts of that protein may be recognised as foreign, and so the animal would then produce antibodies to that specific part or parts, right? Now, when you raise polyclonal antibody, you just put your protein into the animal and then you collect whole blood and you separate out the serum, and that's going to contain all the antibodies to everything, okay? So it's polyclonal because there are a number of clones of B cells that have been activated. With monoclonal antibodies, what you're doing is you're getting only one antibody. It's to a specific part of the protein. So although there may have been antibodies raised against other bits of the protein, you're only using one of them. Okay?
Okay.
So if you raise it to the whole protein in an animal, and what you have to do is you've got to do something peculiar with the spleen, and you have to actually get the B cells out, and you're working with clones, clone lines of B cells, and each clone line is only producing one particular antibody. If you then test that antibody against the target in your sample, if that epitope has either degraded and fallen off in your sample, but although the main body of the protein is still there, but that particular epitope is damaged, then the monoclonal antibody will not react with the protein at all, because it won't react to other bits. Or if the protein isn't even present, obviously it's not going to act. So that's the two possibilities for the monoclonal antibody not giving a reaction, but the polyclonal does give a reaction.
I see.
If that makes sense.
Yes.
Right. And now I'm just looking at something else. Ah, that's interesting. The bit that says negative controls of secondary antibody only showed no binding. Now, if you're doing a blot, okay, well, you get your antibodies from your animal. You've raised the antibodies in the animal, and you're now going to test it against your sample. But they're just bulk basic antibodies. So how are you going to tell if they're bound or not? And what you do is you put your sample and your polyclonal antibodies together, okay? And give them time, see if they're going to react. Then you wash off all the excess, so only the bound stuff is left behind. Right?
Yeah.
Now, if for example, you had raised the antibodies in a rabbit, right? Just for an example, then what you can now do is commercially buy an antibody raised in a goat that binds to rabbit antibodies. So it's goat anti-rabbit, and it's got a tag on it to allow you to actually visualize it. Okay. So you can have a fluorescent tag. So you take your sample, you put your antibodies in, give them time to react, wash off the excess, and then use an antibody to the antibody to detect what's been left behind.
Oh, I see.
So that's the secondary antibody. And the importance of that sentence, negative controls of secondary antibody only showed no binding. So that's saying that the signal that they got can't be down to non-specific binding of the antibody with a flag on the end. And that the antibody with a flag on the end has only bound to the test antibody. Does that make sense?
Yes, I think so.
So you have antigen, you stick the antibody on it, but then you've got to stick an antibody with a flag onto that antibody to detect it.
Gotcha.
And if you just add the antibody with a flag, it doesn't bind because your main antibody is not bound.
Mm.
So it's negative. It's showing that it's not a false positive. I wish I had Lego blocks here because it's so easy to do it with that.
Yeah, no, that's kind of the analogy that my brain is using.
Yeah.
So
The analogies are very, very useful for that. So there you have it. The secondary antibody is going to be an antibody to the primary antibody, and the primary antibody is the antibody to the substance that you're looking for in the sample.
Yeah. Gotcha.
Right. So.
Ha! I'd muted myself.
And the other bit is where they mention about first incubating with excess collagen. These are antibodies to collagen, or so they hope, and they're getting a signal with it. And to test the antibodies, what they've done is they've incubated them with excess collagen, okay? So the collagen is going to stick onto all these antibody binding sites and stay stuck. And then they put the antibodies against the sample. Now, if these antibodies are binding the collagen, the sites are already occupied, so therefore they will not bind to the sample.
Right.
So what that is showing is the specificity of the antibody for collagen.
Yes. Okay.
So
yeah.
So they have to do. They've got to show that they've got that it's not the secondary antibody that's giving the signal, and also that it's not non-specific binding that's causing the signal.
Yeah.
Shown that as well.
Okay.
And these controls are crucial to actually understanding the data that comes out of this.
Yeah. Yeah. Sorry.
And also, if they expose their sample to an enzyme called collagenase, which destroys collagen,
Yes. Well, the name would suggest that.
then the antibody no longer binds in the sample.
Yeah.
That's something else that's telling you that it's the collagen it's binding to.
Mm-hmm.
So all those controls.
Basically, isolating the.
Yeah, the controls are more important than the test at that point. They really are. Because what it's doing is ruling out all the other possibilities.
Yeah.
Okay.
Gotcha.
Yeah. That's great.
I'm not being very responsive in terms of because I'm having to play things back. What you're saying, I'm having to play back, and then I shall watch this hang out again at some point just to.
Yeah, that paragraph there. I mean, it's quite a short paragraph, but the amount of information in that. This is why I had to sit and really think about this. There's so much in there, and you've really got to read it and then read it again. To pull out every single thing that's in there. And because it's explained with such terse words, because obviously space is important when it comes to print journal articles, so it's done in as few words as possible, it can be difficult to pick it up on the first read-through or the second read-through. But that really is a crucial paragraph of the whole paper. Sorry about that, Jade. I have a talent for controls. So where were we?
Oh, okay. Well, actually, I think we were the very last line up there at the top. You don't have to show it. I've got it. It says, because elastin, laminin, and hemoglobin are commonly associated with blood vessels and tetrapods, we used antibodies raised against these proteins to test for epitopes preserved in Bill's vessels. Elastin is a highly conserved vertebrate-specific molecule, generally resistant to degradation, and antibodies to this protein bound dinosaur vessels above background levels in all cases. Both this continues under the pictures, but we can it continues way under stuff. In immunohistory and immunoblot. Let's just stop there for a minute because let's look at the pictures. I think maybe. Yeah, because again, the pictures are showing how they identified everything. If you look at A is the low magnification of that FESM, demineralized, and D, C is the ostrich. So A and B are hadrosaur, C is ostrich. And again, these are things where the where the creationists sometimes, not all the time, will use these photos without, noting that some of them. Again, D is again looking at the D and E are looking at different hadrosaurs, and F, but G is the ostrich. And again, H and I is an ostrich vessel. So see, H shows hollow bill vessels, often associated with osteocytes, and I is the image of collapsed an ostrich vessel, which is an associated mixture with osteocytes. So you can see again what they're doing here is comparing, and if I remember, and so on and so forth. So you can just like look at these on your own, and you can see it. And in figure, they show the immunohistory of demineralized kind of bone matrix and vessels. And I think again they're using, I don't know if they're comparing in the ostrich here again or this. Yeah, see an eye, you've got ostrich again. So again, what they're doing is they're giving you all the evidence that they've shown here. And if you go down a little bit further, you're looking at the mass spectrometry analyses. And again, you can look at this and see, they're giving you all the information on how they compared all this stuff and why it comes out the way it does. Okay, and you go down and you go down. Now, you go down to here to where it shows the, where we start again. Right here, the immunohistory, that's where I stopped. Okay, so let me, so it says antibodies to both laminin and elastin proteins showed specific binding, though they differed in binding strength in both assays. 3 relatively high molecular weight bands can be seen within a smear of stained material in immunoblot, figure 6A, thin arrows, whereas 2 faint bands indicating laminin antibody banding were observed at different molecular weights when compared with elastin reactive bands. Figure 6A is a actually it doesn't appear to be here. Oh, S6A, it says S6A is, well, that doesn't necessarily mean anything because one of the things I wanted to note is a lot of times what you will see, I think the S means supplemental, because this is just the report. You can go online and they have a lot of supplemental information you can download. This is the paper itself. In the supplemental, there will be a lot more of the reports and the data. So I'm guessing that S6A refers to the supplemental. I'll have to download the supplemental because I have access to science and verify that. Anyway, so let's go. Vessel extracts did not show binding to antibodies raised against ostrich hemoglobin, but hemoglobin antibodies bound specifically in situ tests. A second set of experiments conducted in a separate lab confirmed these results. Laminin antibodies known to react to avian and reptilian proteins demonstrate specific binding to Bill's extracts. Controls for spurious antibody binding were negative. Now, what exactly does that mean, Fiona? Controls for spurious antibody binding were negative. I can guess, but
yeah, that was all the stuff I was explaining earlier on.
Right, that's what I thought.
They described all of the different things they did. Incubating with collagen before doing the antibody challenge, using collagenase to destroy any collagen in the sample to make sure that would stop binding as well, and also checking out that the secondary antibody with the label on it wasn't the cause of the positive signal. So that's what that's referring to. So all the negative controls are negative here. They're not flagging up any false positives at all.
Which is really good.
Yes.
And then it says attenuated total reflection infrared spectroscopy demonstrated clear amide 1 and amide 2 bands in lyophilized vessels and surrounding demineralized matrix. This method cannot be used to identify which proteins are present or the source endogeneity, I'm not familiar with that term, of these proteins. Endogeneity. Okay. Endogeneity, okay. it just wasn't coming in my mind, of these proteins only characteristic bond vibration patterns. However, the data are consistent with other in situ data supporting the presence of proteinaceous material in Bill's tissues. And before we go on, if you look at the little thingy on the left, this is the a phylogenetic tree looking at different animals, and you can see where Bill fits in here. You see in the reptilia, the group that Bill belongs to is brachio. Oh God, I even know how to say that.
I know
now I can't say it. Now I can't say it. And
the last couple of times you've referred to it as Bill. It's taken me a couple of seconds to realise that you're talking about Brachiosaurus or whatever it is, rather than
Bill.
Bill
well, that's where Bill lives. Bill lives up there, and the Tyrannosaurs live down below. And so you can see they have a common ancestor, but they've split off, and it's from the Tyrannosaurs and similar relatives that we get.
A gallus, by the way, is a chicken.
Right.
And isn't
Strupio is the it's It's ostrich. Yeah.
Yeah, that's what I thought.
Yeah. That's the ostrich. So you can see that their relationships right there.
Yeah. Xenopus
and they're
frog.
Right.
Say again.
Sorry?
Xenopus is what?
Frog.
Oh, right. I wondered if it was a foreign cat, but...
No.
Yeah,
That's
pretty good. But what a lot of this is saying is, guess what? Bill belongs where he belongs.
Yeah, exactly.
A lot of our earlier, before we had genetics, phylogeny was determined by morphology, physiology, and embryology.
Mm-hmm.
And when people started taking, doing the genetics of various animals, which took quite a long time, because in the early years, it took a very long time and a lot of money to do a genetic analysis. And now, they're zipping around like mad, and people trying to do as many as they can. And as we go in the future, it'll get faster and faster, especially as you start to understand which parts of the genome you really need to look at. You don't necessarily need to look at the whole thing, because there's a big, huge part of our genome and all animal genomes and all plant genomes and all fungi genomes that just tell us that we're eukaryotes. So you don't need to look at that part, things like that. So when they started doing DNA analyses, one of the really great, cool things is they found that, guess what? It matched really, really well everything that had been done before. There were a few surprises, but nothing like way off the lineage. You know what I mean?
Yeah.
It was more like, oh, this came before that. Ooh, oh, wait a minute, this split off earlier, and oh, I see. So it's not a common. It's still a common ancestor, but it's further back than we thought.
Mm-hmm.
So it's basically, there may be discrepancies from what we thought, but it's still the same framework that we're using.
Exactly, and one of those was bats, if I remember correctly. I don't remember the story, but I think they used to think bats were more closely related than shrews than they actually were, something like that.
Yeah.
But nothing really hugely different than what we thought, and every genetic analysis that's been done simply continues to confirm what we knew before. It's filling in the blanks, it's adjusting certain things, and of course we switched to cladistics rather than phylogenetic trees, partly because the phylogenetic trees were really inadequate and didn't show the relationships properly. But it's just so all of this work is showing us that all of the other speculations using different analyses, hey, they're pretty right on. Maybe not exactly right on, but good enough for government work, as we used to say.
Yeah.
Actually, it's better than good enough for government work.
Yeah.
Hadn't come across that.
This is what's so amazing, the way genetics has, yes, it's rearranged a few things, but it actually confirmed a lot of the relationships that we had elucidated. And so in a way what you can say is that the relationships that we'd already elucidated, if they were correct, then that would predict that this is what the genetics should do when we get the sequences.
Yeah.
That's a prediction, and sure enough it was spot on with the predictions.
Yeah, yeah. Now, this chart we're looking at, could you maybe explain it a little bit?
Well, the diagram with Bill and the Tyrannosaurus.
Oh, no, the one below, the one that Shar is showing
right,
now.
okay.
Go back to it, Shah.
Go back. There,
That's
that one right
table.
there. So
It's the table.
Yeah.
that's the table that shows all what they
Right.
did. Yeah.
Basically, what they're doing is that they've isolated what they think is proteinaceous material, and then they have used methods by which to determine the amino acid sequence of these proteins or protein remnants that they've found. Okay? Each letter represents an amino acid. Okay?
Right.
And then compared it to a database.
Yeah.
To identify
That's the
it.
blast sequence, isn't it? The blast.
That's the protein and the blast sequence. So it's the
Protein and the
two
blast
last ones. The column saying protein and the column saying blast. They're the ones that are the results of the comparisons. And the peptide sequence itself is the third last column. So putting those sequences into a database, and that's what you get in the last two columns. They've all been identified as collagen.
Yeah.
Yeah.
And when you look at the sequences that are in the blast that have already been submitted to blast databases, it's hit on both the first one, both ostrich and mammals. The second one is hit on a T-Rex that has already been submitted, chicken and mammals. The third one down is matching with T-Rex, chicken, alligator, and amphibia. So that's what that's all about. There's even an opossum in there. So
yeah,
basically, it's hit these peptide sequences that they've obtained from the fragments of peptides that they've extracted from their sample have given an amino acid sequence which matches what is given in the right-hand column, the known sequences.
and you'll notice that with the exception of the alligator, which we now know is separate from other reptiles, as a matter of fact, they're starting to think of dropping the whole reptile term or splitting it up. We now know that alligators are closely related to birds than we thought. So you notice that with the exception of the alligator, which is completely different, there's no reptiles there.
Yeah.
Yeah, that's the amazing thing about that.
Yeah, that's... Gosh.
So there's like a rearrangement going on because of evidence that is coming to light, and this law also fits in with that evidence that's coming to light.
It fits into what we've already figured out about the alligator, for example.
Yeah.
That the alligators, all the crocodilians, are more closely related to birds than they are to other reptiles, which was a surprise. Now, that's one of those things that was a surprise, but it's not like alligators are no longer reptiles. They are, sort of. We're going to have to reassess what reptile is.
Yeah.
But they're still a common ancestor.
Yeah. But if one of them turns up at your bird feeder, you're not exactly going to be happy.
Yeah.
And you've also put the bird feeder on the floor.
Yeah, I know. I think the alligator would just...
You can get plastic alligators as garden ornaments.
Really?
Yeah, there you go.
I so want one.
Where are you getting these from? I mean, I don't go north of the border until about around Christmas time, but things have changed since last year, if that's the case.
But yeah, to me, that's the really most interesting thing about that. Looking at the blast sequence, there's no reptiles, except alligator, which again is questionable.
Yeah, and yet we get an amphibian in there.
Yes, that's interesting too.
Yeah, but only in the one.
Alligator's in there several times.
Yeah, so that's really interesting. Really interesting, but every single time it's hit on collagen. So there you go. So that's what that table's all about. I mean, forget about all the stuff up at the left-hand side, because that's various bits and pieces that are telling you bits of information about the protein that really, I'm not saying they're irrelevant, but we can actually see what the table is telling us without having to go into all of that.
Right.
Yeah. But we're now going to get down to an audible bit.
Yeah. But with that, just like we saw with the Tyrannosaurs, which didn't react to reptiles, to reptile serum. Again, seeing no reptile here, with the exception of which may no longer be a reptile.
Yeah, but also the next paragraph. Just keep your table in front of you. The next paragraph said post-translational hydroxylation of proline is an identifying feature of collagen, and microbes cannot produce this modification.
English?
Right.
Layman's English, because it is English.
Post-translational hydroxylation of proline. Right. Proline is an amino acid, okay?
Yep.
Right. Now, after the protein has been made, the amino acid chain has been put together. That's translation.
Okay.
And it separates from the ribosome. And then there is a post-translational modification done. And it's a hydroxylation of the proline. And if you look in the table, and you look at the peptide sequence, and look at the P's, you'll notice that some of them have got brackets OH after them.
Yes.
That's a hydroxylated proline.
Okay. Yeah, that makes sense.
Right, and as it says, microbes cannot produce this modification.
Yeah, that's
so that's it's another piece of evidence that this isn't from microbial contamination.
Right.
Because this feature, you're not going to find in microbes, in bacteria, etc.
Right.
That's cool.
Gotcha.
Right. So again, it's one wee tiny sentence there. And yet, it's another killer blow for the contamination argument. And it's a really important sentence.
Yes.
This is one of the things reading papers. Some of the bits that are, the wow factor can be one wee sentence tucked away in a corner. You really, when you read papers, you've got to read everything.
Yeah.
Including the legends below figures and tables and everything, because the amount of information there is incredible.
Yeah.
So there we have it. That's, again, not microbes. The actual peptide sequence that they've got out, one hits on collagen, and two is showing a modification that would not be found in microbes.
That is cool.
That is cool.
Yeah.
Yeah. Yeah.
So
again, this looks like it's all Bill's.
Yeah, it all belongs to Bill. And after this, once we finish this paper, I want to kill Bill.
Well,
yeah, don't say that too loudly. The next installment will be a Tarantino movie with a dinosaur.
I know.
Oh. Right, so
well, we're almost done.
Yeah, it's now going on this bit.
Yeah, I was going to say, let's finish this one and we're done, I think.
Whole vessels and matrix from demineralized billbone were subjected to, you'll love it, were subjected to in situ time of flight secondary ion mass spectrometry. We'll call it TOFSIMS, with imaging capability in a separate laboratory. Focused gallium and gold ions generated molecular fragments from tissues that were detected with sufficient high mass resolution to uniquely identify hydroxylated proline, as well as lysine, proline, hydroxylated lysine, alanine, glycine, and leucine from demineralized dinosaur tissues. A number of organic fragments were containing nitrogen were also detected, including unusual complexes between carbon, nitrogen, and iron, suggesting alteration and modification to preserved organics more consistent with an ancient source than recent contamination. There's another one again. Forget the recent contamination.
Hmm.
And that's about as much as you need to say about that paragraph. I mean, come on, in situ time of flight, secondary ion mass spectrometry. That's a mouthful. Now I'm just going to look at this. So they use mass spec to analyse whole bone extracts of Bill that were fibrous and lighter in colour than those from T-Rex. Bone extracts were proteolysed with trypsin, purified and concentrated by micro-reversed phase chromatography, and then analysed by reversed phase microcapillary liquid chromatography, tandem mass spectrometry, using both linear ion trap and hybrid linear ion trap orbit trap mass spectrometers. To be honest, guys, see that bit there?
Which bit? Sorry.
Exactly. That gobbledygook. I mean, we're talking about it's great big long names for procedures and for instrumentation, okay?
Yeah, okay.
So we don't need to really go into that.
Yeah, I should say for the record, I have a lot more. I could have pulled you up on a number of things there, but frankly, there are a number of reasons why I did, not least of which my voice is giving up.
Yeah, I mean, honestly, that is
verbose.
Yes. So I'm going to get we identified. Oh yeah, sorry. That's how they isolated the proteins that they then sequenced. You to get the peptide sequence, which is what we looked at on the table. We identified 8 total collagen peptide sequences, 6 from collagen alpha 1 type 1 and 2 from collagen alpha 2 type 1. The 8 peptides totaled 149 amino acids from 4 different samples. Nearly double the number of amino acids recovered from T-Rex, more 1125. The 8 peptides identified as collagen in the table were top-ranked matches versus the SWIT-PRO's target protein database. 4 of the 8 peptides derived from 3 separate bone extracts and were subjected from multiple scan events across multiple data files. We validated the sequences using scoring statistics, decoy databases, manual inspection, and spectral comparisons to high-confidence spectra obtained from synthetic peptides and peptides of identical sequence from extant organisms. One peptide sequence showed evidence of deamidation of asparagine, and all reported sequences contained at least one hydroxylated proline residue.
What's deamidation?
The deamidation, if you go up to the table again, right, and you look at the second one from the bottom.
You back one.
There's a deamination there. It's an amino group that's been removed. Remember, these are amino acids.
Where am I?
On the table.
Yeah.
The second sequence from the bottom is a collagen alpha 2-1.
Yeah.
It says GSN brackets deam.
Gotcha.
That's your deamidation there.
Gotcha. Okay.
Right?
Yeah.
Where was I?
Sorry to
Right
keep
here.
Yeah. So the 8 peptide sequences for collagen alpha 1 type 1 and collagen alpha 2 type 1 represent 7.8 and 2.5% of the full length sequence for related organisms. So basically, the sequence that they got out is only 7.8% of the alpha 1 type 1. Or 2.5% of the alpha 2 type 1. Now that's not talking about the matches. It's talking about the size of the fragments that they've managed to get the sequence from. So they've only got a sequence from either 7.8% or 2.5%. That's all that remained intact in sequence.
Okay.
Okay, so we're not talking about an entire collagen molecule here. They've managed to sequence a fragment of it. if that makes sense. So we're still not even saying that the collagen molecule is intact. Okay?
So like, is that representative of like these chains? Is that the fragment we're talking about, or is this a part of the fragment?
Let me see, where are we? That's the fragment. That's the fragment that got,
Okay, gotcha.
right? Where the actual collagen itself would be much longer.
Mm-hmm.
Okay? So that's all they've had to work with there. This is why they've done so many ways of comparing them, including by eye, and also the computer algorithms that compare sequences, because that's quite short.
Mm-hmm.
Now, the next bit is really important.
Okay.
If we go down to this, co-extracted sediment and buffer controls were consistently negative for collagen peptidic material by all methods of analyses, including mass spectrometry sequencing, although common contaminants, including human keratins, ubiquitous in all labs, and some microbial peptides were sequenced from these bone extracts. So,
Okay, so tell me why that's really important.
right, what they're saying is that when they do all these same tests in the sediment that surrounded the bones,
Yeah.
they're negative.
Okay, right. Gotcha.
And when they do the tests, but with just using a buffer control in it, no sample, they
Yeah.
still get a negative.
Right.
So it's not the methods that they're using that are causing these results to come up.
It's the sample.
Yeah, but they do say that they did find human keratin
Yeah.
and some microbial peptides.
But weren't that what I took from that? And I could be completely wrong. What I took from that is that they would expect to find those because there's only so much you can control
Exactly.
an environment.
Yes. Even when you're gloved up, there's the odd skin cell that's going to flake off your face.
Of course.
What I took from that was that humans lived with dinosaurs.
Who knew the Flintstones was a documentary?
Right. Wait. Are my arms long enough to actually reach her?
Okay.
I mean, what can you do when somebody on your own side your wee rug is under you? Honestly, woman. Oh, do you know have you ever noticed there are some people that you used to like?
People normally say that when they refer about me.
Well, that was actually very funny. But I'm still going to kill you. But yeah, the thing is though, that is something that would be used.
Yeah, I know.
Yeah.
And yet that's not what it's saying.
I know.
Ubiquitous in all labs. This is the problem. Because when you do these analyses, you will find that in your samples.
Yeah.
Just because of the lab environment. So there you go. And given that you have to do an awful lot more work with the bone extracts, obviously they're going to be more contaminated than your controls,
Yes.
your buffers, etc.
Yeah, that makes sense.
Right, so I'm back up. I'm looking down. I'm going to try and miss, the real gobbledygook in this, like LTQ, Orbitrap, XL mass spectrometers.
Sounds like a Star Trek episode.
Yeah.
Yeah. All that gobbledygook.
I'm trying to put in the scoring. And they're just saying that they were very stringent with their testing. And they tested these sequences, the peptide sequences they got against a database of over 200,000 random peptide fragmentation spectra from various taxa. It's basically been comparing what they obtained in all sorts of different databases and coming up with the same results.
Yeah. Essentially, they're checking their working here.
Yeah. The 4 sequences derived from Bill were top matches to high confidence versions of the same sequences by fragment ion mass charge ratio values, and relative intensities of fragment ions provided additional validation of the data. All sequence data from Bill and validating sources are available in the support and documentation. Okay? So in addition, we've shown that Bill's collagen sequences to be statistically significant, and false discovery rates have been calculated.
What if? What? Now I think I know what that means, but false discovery.
I think it's going to be false positives.
Okay. Right.
Given all the tests that they've run, they've calculated the chances of it being a false result that they've got. And that's reference 10, you'd find that in, I think.
Okay.
Right, so let me see. Right, in a separate lab, Bill bone extract showed positive reactivity by immunoblot to a mixture of collagen type 1 polyclonal antibodies at high molecular weights, whereas surrounding sediments showed negative reactivity. So again, sediments are negative, so this must be the bone itself. This supports identification of collagen fragments in bone extracts and suggests modifications, for example, cross-linking of collagen molecules. Although silver-stained material in gels suggests concentrations within the low end of the current mass spec sensitivity thresholds, so we're talking about really low nanogram amounts, it is likely that most of the protein is present in unsequenceable forms, that is, cross-linked and or modified, so as to make them incapable of resolution by current mass spec technology and software. We hypothesize that processes contributing to preservation of these otherwise labile components make analyses difficult, but conversely the low recovery and diagenetic alteration support an endogenous source, as these chemical modifications are not observed in modern proteins. So again, we're ruling out any contamination.
Yeah.
Okay.
Gotcha.
And then it's going into the comparison of the sequences obtained from the collagen in the samples with sequences of collagen from 21 extant taxa and 2 extinct organisms, Mammoth americanum and T-rex.
Okay.
The Anolis carolinensis amino acid sequence was inferred with the use of FGENESH plus gene prediction, etc. software. So the amino acid sequence of the Anolis is worked out from the nucleotide sequence. Okay, so a computer has translated it into what the protein sequence would be. That's why it says it is inferred. Okay.
Yeah.
Now, and also it's obtained from public online databases. I'm trying to just miss out a lot of the gobbledygook in here. Right, whereas the first molecular phylogeny containing a non-avian dinosaurian, T-rex more 1125, resulted in a tree that misplaced carolinensis, additional sequence data from several extant species corrected this misplacement and improved clade support to 100%. That's the number of times the clade was inferred.
Okay.
In the distribution of the trees for all groups except the Gallus Struthio group, which had 36% support. Under a majority rule criterion to building a consensus tree, Dinosauria, the group containing the 2 extinct dinosaurs and the 2 birds, collapsed into a 3-way... What? Polytomy. Yeah. So, removing T-Rex from the phylogeny resulted in a 3-way polytomy, or polytomy as well. The amount of missing data in Bill and T-Rex sequences relative to extant samples resulted in relatively low resolution within Dinosauria, but even so, the phylogenetic relationship of recovered Bill sequences supports the species placement within the Archosauria, closer to birds than alligator. However, on the basis of well-established morphological analyses, we predict that T-Rex is more closely related to birds than it is to the ornithischian hadrosaur Bill. So it means that T-Rex is actually closer to a bird
Yeah.
as to Bill.
Yeah, there it is. Yeah.
Despite ambiguity within Dinosauria, obvious phylogenetic signal residues within recovered collagen sequences supporting endogeneity.
Gotcha.
Now,
Wow.
now this is cool because this backs up other research that's been done that shows that there is a difference between, like the hadrosaurs in the group the hadrosaurs belong to and T-Rex in the group T-Rex belongs to, which has already, by using, again, morphological details, that T-Rex is closer related to birds. That was already assumed. And, whoa, it works.
You've just found that you've just been vindicated.
Yeah. This is why, again, see, all of the work that was done before we had all these techniques and before we had, before Schweizer did her discoveries, and, before we knew what we knew about genetics, and, all of this stuff is still working out. Again, there are some errors, there are some slight misplacements, but they're not extreme. Probably the most interesting thing has been the recent replacement of the crocodilians, but yeah, this just backs up what the work, and what this does is this helps confirm the work the paleontologists are doing by examining bones where they don't have any tissue that they could get proteins or DNA or RNA from. That's pretty cool.
Yeah, I wish I had something more intelligent to say other than that's pretty awesome.
Yeah, I mean that's what I'm thinking too. It's pretty awesome. I've read this paper before, but I really wanted Fiona here because there's a lot I didn't get. I'm better with the other 2 papers and the next paper, the osteocetes one, because there are stuff. I mean, I'm an amateur at this. I understood enough to know where the creationists were wrong, but yeah, this is really cool.
Yeah,
I just downloaded something like 20 PDFs that are about 20 pages each, that are the lectures from a class in vertebrate paleontology. I found them online, and I downloaded them all because you never know when this stuff is going to disappear. And then I was scanning them as I was going, and it's really, really cool. And it's one of the things that I know that this is, because in all these lectures on vertebrate paleontology, they show how you look at the different bones. They show how you look at the skull and how you look at those damned fossa. That's the fossa are holes in the head. And I say damned fossa because I
was going to ask you why.
Well, I belong to the dinosaur mailing list, and there are always people get excited about skulls. Oh, look, there's 3 holes here, and they're in the right position. I don't care about the damn fossa. I'm more into limbs. How limbs articulate and work, and for a while there, every time something new came up, people were talking about the damn fossa. So it just became stuck in my head. as damn fossa. But so they look at the different the way the holes are in the head, the way they're established, the way the different bony plates of the head fit together, the way the different limbs go together, and it's and using all of these things is how they've determined phylogeny.
Yes.
Because, and what we're seeing now with the papers we're looking at is that the phylogeny that was done using these methods is substantiated by this work.
Yeah.
Which helps hold up the other work that they've done. We don't have any. In other words, there are a lot of dinosaurs, a lot of prehistoric animals, excuse me, that we don't have this kind of information from.
No.
We haven't been able to extract anything from it. But what this is telling us is that the work that paleontologists are doing really works.
Yes, the process is good.
Which is very cool.
Yes. Yeah.
And their assumptions, earlier assumptions about theropods and the relationship between, birds and dinosaurs, or birds are dinosaurs. I actually followed that whole argument for a period of about 30 years. Are birds dinosaurs? Are birds not dinosaurs? Are birds dinosaur descendants?
Yes.
Until they finally settled that birds are dinosaurs. They're theropods.
Yes.
And that was interesting to watch. And, I was just an outsider watching these in this mailing list, watch the actual paleontologists argue this stuff out. It was kind of fun.
Yes.
And so it takes, it took a lot of discussion before and a lot of research before they decided, yeah, birds are dinosaurs. But all this work, it works. It fits. It's fantastic.
Yeah.
And why people want to reduce this to what younger creationists want to, I don't understand. It's so fantastically wonderful.
Say again. What was the bit you didn't understand?
Oh, it's why young Earth creationists try to dismiss all of this and try to poke holes in it.
Well, it's because, well, to my mind, and I'm not a scientist by any stretch whatsoever. I'm just about keeping up, and the treadmill's on its highest setting during this discussion, but I'm just about keeping it. But the thing, to my mind, when anyone talks about creation science, it's a misnomer. It's not science, because it goes back to what you're saying about the process and being able to make predictions and such. Creationism does none of this. It's really just a dogma wrapped up in a lab coat, and it's someone walking around in a lab coat pretending to be a scientist because they've got a lab coat on. It's willful manipulation of the scientific evidence to prove and drive home a point rather than actually looking at the evidence itself. It's a complete bastardization of the scientific process as a whole.
And yet this is so wonderful. That's the whole thing. And the more we discover, the more it fits.
Yeah, but Jeebus.
It's exciting. Yeah, but most people in this country who are Christians, well, not in this country, but not necessarily most people, but most Christian groups, Christian sects, I can't even think of the right term I'm using, actually accept evolution.
Yeah,
I mean, the Pope just came out and said, yeah, that's the way they did it. And that's not the first time that was said. He just sort of firmly put a stamp on it.
Yes. Yeah.
During the Darwin year, the Jesuits actually had a conference on, creation and evolution, but what they meant was, God's version of creation. And the young Earth creationists showed up, and they were turned away.
Yes.
They weren't invited, but they showed up. And they were turned away because the Jesuits said, that's not science.
Yeah.
And they were really pissed off about it, too.
Yeah. It's lovely when that happens, isn't it?
Oh, it was beautiful. I've got all the references for that. It's on my other computer, but yeah, and it was some of the big people in the ID community. They showed up to think that they were going to be able to participate in this Catholic conference. They were turned away because, sorry, that's not science.
Bless.
I know. I just think it's freaking hilarious.
Oh.
And Episcopalians, both Lutherans, a lot of Methodists. We just have a unique situation in this country where we have all these fundies.
Yeah,
And they're not just science denial. They're science denialists. It's not just evolution. It's climate science. How the hell they get that one in there? It's just really weird. But yeah.
Well, that's willful ignorance again. I mean, it goes back to what you were saying earlier. We were discussing the Noah's Ark, the literal Noah's Ark people. It goes back to, if you've got God, if you believe in an omnipotent, omniscient God, why not just say because God?
Mm-hmm.
Yeah.
It makes so little sense to try and.
And why God did it this way, we don't know. That's God's business.
Yeah, all you have to do is say God did it, and we don't need to know why.
Yeah.
Did you want to say something, Fiona, or are you just whistling for no particular reason?
No. I just saw something in the background. I had forgotten I had the program open.
Oh.
I got this great big alert that just came up.
Say again.
It was a big alert coming up.
Oh.
It's because of the number of earthquakes in certain areas going over a certain threshold. Don't worry about it.
Oh.
And I was just gobsmacked at how many there have been.
Oh, well, where are these earthquakes?
They're Indonesia.
Oh, okay.
Oh, well, that's not surprising at all. I get the I get the earthquake alerts from the USGS every day, and
Yeah,
Indonesia is like the hot spot.
Try this one I'll just put this into the chat. Try this for size. It auto updates itself.
Okay, cool. Yeah, because being a Californian, I'm really interested in earthquakes.
Yeah, as Robin Williams put it, if you're in California, you live on God's Etch-a-Sketch.
Exactly.
Yeah, no kidding.
Yeah. That is a fascinating piece to keep. You just keep it open on your desktop and it updates itself.
Oh, how cool. Yeah.
Brilliant, isn't it?
Yeah, that is cool.
Yeah, and I've been tracking the earthquakes. And they work their way up the coast of South America, up the coast of California, around Alaska, then down past Japan, down the other side. And
that's the Ring of Fire.
Yeah, you can tell when there's going to be a big one due. Because you've got lots of little ones that seem to add up and stop and don't go any further. So they're tracking round, but they all keep stopping. And you know that where they've stopped, then in the next few weeks there's going to be a biggie to release all of the strains from the little ones. It's something I've been watching for years to see if that theory holds out, and it does.
Cool.
In fact, it was a big 7.3 in that region a couple of days back.
Wow.
But it looks as if the strain has been split. One part going up towards, Sumatra, and the other bit going down across the north of Australia. So the strain has been split.
Yeah, I'm looking at it now.
So there you go. Sorry about that. It was just.
No, that's pretty cool. I like this, and
I'm
looking
flashing on my desktop. Wow.
Yeah, Kansas had one that was kind of a surprise for them.
Oh, well, it would be. I got one in California. San Francisco was in. I wasn't surprised.
Well, we may have had a little tiny earthquake while we were having this hangout. I'm not sure yet.
Well, I don't know about Kansas, but they've certainly been having a lot of trouble.
I'll have to look it up. The reason I'm not sure is because I'm on alluvial soil. This is old creek bed here, and if a big heavy truck comes by, occasionally it feels like a small earthquake. And because I've got my earphones in, my earbuds in, I may not have heard it. But yeah, there was definitely a little bump while we were talking. It was either a truck, but it was very small. So it was either a truck or a small earthquake, neither of which would have surprised me.
We've only got one last paragraph here, right? I'm going to read it out.
Oh.
Right, submicron differences in texture, elemental differentiation, subcellular in quotes, inclusions in osteocytes and vessels, identification of the post-translational proline hydroxylation modification not produced by microbes, differential binding of antibodies by both in situ and immunoblot studies, collagen protein sequences and phylogenetic analyses do not support a microbial origin for either these microstructures or peptide fragments. Coupled with evidence for cross-linking and unusual chemical modifications, the congruence of evidence strongly supports an endogenous origin for this material, i.e. it came from Bill. The
Right.
most parsimonious explanation thus far unfalsified is that original molecules persist in some Cretaceous dinosaur fossils. Still unknown is the chemistry behind such preservation. So that last wee paragraph is like a little summary pointing out that all of the results in this study are supporting that this is the collagen that is preserved in the bone, that is coming from the bone, and that it is not contamination. But you'll notice that nowhere in there do you get any implication that we're talking about soft tissue as like a lump of meat.
Right.
Which is what the young earth creationists like to quote Mary Schweizer's papers as saying. I mean, I've even had somebody make the argument after reading this one, well, if it's that old, how come it was producing antibodies? Because the word antibody was used in here. Yes, they were using antibodies in the tests. And also, there's the idea of, well, how could an antibody react to it if it's all broken up? Doesn't that show it's living? No.
Oh, yeah, that's a good point.
Yeah, that's something, I think it was Tommy Hall thought that if the antibody was reacting, then it must be like proper active. He was talking about active soft tissue. No.
Oh, God.
Just no. So, given, I mean, when you look at everything that was done in this paper, and they're using mass spectrometry, they're using protein sequencing and all the rest of it, we're not exactly looking at a slab of meat.
No.
We're right down at the molecular level here. We're talking about not even a collagen fiber, but the remnants of collagen. And that, I mean, collagen, while it qualifies as a soft tissue, that's the stuff that makes up your nose.
Yes, it's the
yeah, and you get cartilage. I mean, it's high in collagen. Collagen is very resilient.
Yes, I can't remember what.
And this is what seems to be getting preserved. It's actually broken up collagen.
Yes.
Mm-hmm. Yeah.
And that is so far from a steak.
Right.
Yeah.
Yeah, but that's not the way it's presented. Yeah.
Exactly. But when you go through these papers of hers, you realise that they've noticed certain buzzwords and just run with them.
Yeah, that they latch onto them because it sounds like it's what they want to argue.
Yeah, and that's a big problem. That's something that needs to, I said, be dealt with. It's something that needs to be corrected when it goes out there.
Yeah.
But by the same token, we have to expect that this type of honest misrepresentation is going to happen.
See, I'm not sure how honest it is.
Well, people have got their information from those that are dishonestly representing it.
Yes.
Like anthropogenesis. So they've gone along, they've read that, and in all honesty.
Yes, I would totally agree.
Yeah.
Yeah. And the people who are responsible for these sites, they know that they've got it wrong because they've been corrected so many times, but they don't correct their websites.
No.
Well,
and so they're fooling their own followers.
Well,
That's
see,
the part that pisses me off most.
well, because the thing is that you say that, Fiona, but I think the thing is that when it's the corrections come with a personal attack after it, it sort of like lessens the correction, if that makes any sense. Because usually what you'll find, I mean, because like, I mean, it'd be like, I mean, like, I don't know what the field's like, but imagine like if like somebody made a mistake in the field and you spotted it, I don't think you'd tell go up to somebody and go, well, that's wrong, you absolute idiotard or whatever. You just
Well,
go,
it depends who had made the mistake. I mean, if my husband came to me and said, I'm having trouble with this experiment, I'm going to look through my methodology, and I found a problem with it, I would say, you cretin.
Yeah.
I mean, I do understand what you mean, but the problem is this, and this is something that I've come across time and time again, it actually works the other way around, that when you try to correct this misunderstanding, you're the one that gets the insults thrown at you.
Yeah.
That's what I think.
They do it to suit themselves.
Because you just need to look back over the last week or two to see where this has got me.
Well, exactly. And I just wish I was surprised.
Yeah, and so for that reason, it's like, almost like ploughing a rather lonely furrow here. But you can't let the misunderstandings stay out there. But the other thing is, and I will admit that occasionally I will do a correction with a bit of an attack. And that is when it is the same person spouting the same erroneous material for the 10th time.
Yes.
And asking me the same question for the 10th time, as if it's never been answered.
Yeah.
Because that is where you say, no, this is no longer an honest mistake.
Yeah, exactly. It shows they're not engaging in the discussion process whatsoever. They're just there to troll.
But
Yeah.
I think a huge part of that whole problem is that so many of these people, like these young Earth creationists or just non-science, or the I don't know what you call them, the antagonists in the whole equation. I think so many of them are so focused on having absolute certainty about everything, and that's not how science works. So if you give them, the best answers we have, they're not satisfied because you can't tell them that it's 100% accurate truth, no questions asked. And that's what they want you to give them.
Yeah. A prime example of that is Revelation News lately. Because he keeps asking people he wants scientific proof of what happened before the Big Bang, or before the singularity, one or the other, I forget which. But he wants to know what happened before then. And he says, you see, nobody can tell me, nobody can give me the answer, but we have a book that tells us the answer.
Oh, good grief.
And the thing is, yes, you're right, we can't tell you because the math only goes so far. Not only that, when you get to a certain point, the math doesn't work anymore.
Yeah.
So we have, this is why Lawrence Krauss and others, and I know this is one of Gary's kind of bugaboos, when they say, there's nothing there. They're not talking about there actually being nothing there. It's just there's nothing we can measure at that point. We have to develop a new math, a new physics, and maybe somebody will figure it out. And then we can go back a little bit further. But right now, no. Science. Science does not speculate wildly.
Okay, but the thing I have a problem with, Jade, is saying it's a universe for nothing when it isn't nothing.
I know that. It just, the point is, it's a different definition of nothing, and yes, it's a bad term. It is a bad term to use.
It's actually an accurate term. That's what it is.
Yeah. Well, so is the Big Bang.
Because it isn't nothing. A vacuum state is not nothing. It's something.
Right.
It doesn't have any mass.
It's nothing we can measure. Is the best way to put it. It's not that there's a nothing. Let's put it that way. It's not that there is a nothing. There is nothing we can measure,
Well,
or
part of the
nothing
reason
we can figure out yet.
I think part of the reason for the use of the word well, there's lots of reasons for the use of the word nothing, and one of them just being that it's sort of something that the layman might understand.
Yeah,
Right?
there's a point to be said for common parlance here.
Yeah.
Yeah.
But I think the other part of it is that there's still this misconception that the universe came from a tiny ball of immense mass, right? Like there's still this idea that there was just this ball floating around and it exploded into a universe, and it's like, no, that's not it at all, right? So so in contrast to that, it was nothing. It was no mass. It was no matter, right? So I think there's that as well.
And the Big Bang is a misnomer. There was no bang.
Yeah.
Yeah, there was big. Well, and it was very small to begin with. Anyway.
Yeah, it wasn't big. It wasn't big, and it wasn't a bang. It's a bit like the old joke about the Holy Roman Empire. It was neither Holy Roman nor an empire.
Yes.
Yeah.
Well, Jade, I mean, what universal method do you go by? Do you go by crosses, or do you go by the multiverse theory, or do you go by M theory? I mean,
I don't. How's that for an answer? I don't know enough to go by any of those. So that's my personal opinion.
Yeah.
I haven't investigated it enough. Most of my reading tends to be in biology and paleontology and history. I don't, and as well as reading a lot of literature and some philosophy. Mostly the ancient philosophers. I'm still stuck in the. I'm still stuck in ancient Greece in many ways. Ancient Greece and Rome. But I don't know enough about that. I avoid commenting on that subject altogether because I simply don't have a knowledge base even begin to comment on it.
Like
I'm going to have to go.
Okay, well, goodbye. And I was thinking this was a good time to stop anyway, and we've got another paper, but we can do that another time.
Yeah, because it's after 2 o'clock in the morning now.
Yeah.
Sometime in the near future, we're gonna have to look at this whole 250 million year old bacteria that they found.
Okay, because I love this stuff. I would like to continue with our little journal club, so to speak. And
yes, I think it's a really good idea. This.
I learned so much from it, and when we have different groups of people who, with different perspectives, can ask questions. And as much as Gary is constantly apologizing, I think he's very important.
Yes,
he is. But you see, the thing is, what he's doing is he's asking questions to get an answer. He's not asking questions as a gotcha.
Yeah, I mean,
and Gary, I'm with you in that I'm a layperson to most of this. I mean, I can just about grasp most of what's been said, but I was always taught that there's no such thing as a bad question if you genuinely don't know the answer and are looking for it.
Yes, exactly.
Yeah.
Gary asked a couple questions I wanted to ask too, but I have cats fighting tonight and husband banging around, and I was muted quite a bit.
It's probably the stuff I'm answering is like probably the stuff that Fiona's learned on part day one of biology or something like that, and it's probably like ridiculous to her that somebody doesn't know it. Maybe
no, I don't think so.
No, I don't think so.
Yeah.
I actually think that Gary is saying, I don't know the answer to this, going to tell me. And that's a huge difference from somebody who is coming along in a similar position to Gary saying, I'm going to put all these scientists right.
Yeah.
And, I have to ask the question, do you really think that scientists wouldn't have noticed this? When they come up with some of the questions, it does beg a belief that they don't realise that if you specialise in a field for years, you would have noticed.
Yeah.
Well, I'll just say this. The thing is that we brought up Murray before, but maybe what he's bringing up is something they haven't noticed. So if you could bring it forward in a coherent fashion, maybe it's something that maybe
Yeah.
discussed. I'm not
You
so,
see, more often than not, stuff that's being brought forward because the person bringing it forward is unaware. Not that scientists are unaware. Those working in the field are aware,
Mhm.
and they know why it's nonsense.
Right.
And just because the person bringing it forward doesn't know, it doesn't mean that nobody knows. You know, when
Right.
you give an answer and you get, well, I've never heard of that. Well, you know, colour me very unsurprised, because there's a heck of a lot of things about the running of a nuclear reactor that I've never heard of. It
Yeah.
doesn't mean they don't exist. Doesn't mean that the people running the nuclear reactors haven't heard of it.
Exactly.
But
Yeah,
anyway, on that
exactly.
note, I'm going to have to go. So be good. Take it. Oh, by the way, check out the new banner on my YouTube channel.
Oh, we were looking at that before we started. We found it, and we're just loving it. It's fantastic. I love that.
I haven't seen this. Hold on.
You missed it. Okay, you'll have to look at
Oh,
it.
I've just put it up. Fiona, you just won.
I love it. I love it. The one last thing I would like to say is the papers we are looking at are actually older papers. The one we just read is from 2009. There's been a lot more work, including about, as I said, iron as a preservative in a sense. Don't quite take that literally. And I'm going to try to find those papers because I have access. I have access to the journal Science and the journal Nature.
Good.
So I can pull up this paper, and you know I can actually send the papers around to people if they need to be. So we can look at these, even the ones that aren't. But I wanted to start with the public domain ones because they're public domain.
Do you know what we should do? Start sort of semi-regular hangouts, just called the Journal Club.
Yeah, I think so too. And now that you're on Skype, well, maybe we could set up a Google Plus group or a Skype group to call the Journal Club. And that way we could send the notices out to somebody, or if we needed to change the date or time, or somebody couldn't make it.
Yeah. I think, and also, I mean, get people to maybe bring forward papers that they're interested in and they don't understand.
Yeah, that'd be.
Yeah, like Shar just did. I mean, I think that's perfect.
Yeah.
Let's do that because this is how we learn.
Yeah. So on that note, I will bid you adieu.
Okay.
Be good.
Good night. Hope you feel
Take care.
better. So glad you made it.
Yeah, thanks.
Okay. Good night, Fiona, or good day.
Good night, Lee.
Okay. So, I guess we're probably done here. I know a lot of people aren't watching right now, but I also know some people do tend to watch later. And if we do start to do this as a general thing, I think it'd be pretty cool to, you know, we could send out notices to everybody. I think maybe, you know, what we could do is we could, set up a Skype group or a Google Plus group and just send out notices. And then if somebody can propose a paper ahead of time, if we're totally clueless about it, you know, we can look at it ahead of time. Maybe find someone that could help us. I remember Fiona once brought in a geologist she knew to discuss some stuff. So you know, we can look at things like that.
Well, I was thinking, Jade. Well, I know this might not be a popular idea, but do you know that Jason, our friend Jason, that's that he's a scholar? But I thought that we could look at some of Francis Eliot's stuff that he misquotes and doesn't understand.
Yeah.
Yeah. Okay. Yeah.
But because I know the fact that I know the fact that if I contacted Francis Eliot, he would not be very happy about the sort of things that Jason says that he believes.
Might I suggest that as we're talking about specific individuals, we take this hangout off air?
Yeah, let's take it off here. We're done. Yeah, we're done now. So thanks everybody who watched, and I hope you you know, come along again, and we're going to start a journal club, and we can for people who you know, maybe we should even and just for people who want to know about it, so we can eventually send out notices when we're going to have hangouts and things like that. So stay tuned. Goodbye.
That is people.
Bye.
Anybody else want to say anything?
Right.
No.
I have any progress in 5, 4, 3, 2, 1.
Okay, Gary, kill it.